base, we just start the intermediate level. Okay. So we go through the link aggregation, VLAN principle, VLAN routing, HDRC and PPP, PPPoE, and then the last topic we done for yesterday is NAT, network address translation. So today we are going to the first topic of the day will be ACL, access control list. Okay. Access control list. So, okay. So other than this, we'll also go through the AAA, the AAA topics, and then the securing data with IPsec VPN, and also the GRE VPN. And hopefully we can go into SMP, Simple Network Management Protocol. Okay. So let's start the topic. Okay, access control list, ACL. So access control list, ACL. If you just read the words list, it's a list. Access control list is a list of rules. Let's see what are the rules. What we can do with this ACL. So many technologies and protocol depends on ACL for greater management and filtering of traffic as part of security measures or application requirements. So ACL it can be used to filter the traffic, or even as a security. It's a security features, but also can help for management, greater management of traffic flow, and then application requirements. Okay, so you have to understand how to implement this. Okay, let's see. So I will describe the applications for ACL in the enterprise network. In what scenario we are applying ACL, and then I'll explain the decision-making behavior of ACL. Then successfully we will do the basic ACL and advanced ACL in the ENSP. So for ACL, we'll do it for two purposes. We can have for two purposes we can implement this. First one is to filtering the restricted traffic. Filtering restricted traffic. So packets are filtered based on addresses and parameters. So rules allow packets to be either permitted or denied. Okay, so according to the rules in the ACL, so the packets can be permitted or denied. This means the traffic flow. If the traffic flow means the transmitting and forwarding of the packets. Okay, so from this diagram, you can see the red color arrow, the red color, this is the traffic flow from network 192.168.1.0/24. So this traffic from this network. So we'll go through this switch. So this switch is just this switch just a layer 2 switch. So you go through the router. Okay, go to the router as a gateway, either to access the internet or access the server. So when the traffic is come upon the router, okay, the router. So the traffic of this, the router can decide based on the rules defined in the router, in the ACL. So these packets can be permitted to access the internet or denied from accessing the server. Okay, so and then for this packets from network 192.168.2.0. So you can see very obvious. This is two different IP address. So let's say this blue color traffic from 192.168.2.2.0. So also same, both reach the router. The router is the gateway to either to analyze, to check the source IP address or the destination IP address or other parameters we can define, and then to decide whether the packet is be permitted or denied. So this blue color is denied from accessing the internet, but is permitted to access the server. Okay, then next one, the next purpose of the ACL is to filtering the interesting traffic. So you're going to find out, maybe you want to do something with that certain traffic, with that certain IP address, or with that certain destination IP address. Okay, so you can use also can use the ACL. So the example here is the same thing. 192.168.1.0, 192.168.2.0. Okay, so somehow on this router already configured, if the data, let's say, if the source IP match 192.168.1.0/24 from this network. So if this is, let's say, no match, okay, I should say 192.168.1.0 source from or the packet source from this network. If that doesn't match, if it doesn't match, no match on the ACL, so the data, okay, the data sent out will be continued as data sent to the router. The router forward it out as a data, no changes at all if no match. Okay. So if for the packets, for the traffic coming from 192.168.2.0, so if let's say this is no match, okay. So if this the traffic the packets coming from this network match the, let's say, match the rules. So the rules can be one of the result. If you match, it will be encrypted the data. So this means that mostly we'll see this in the configuring the IPsec and the GRE. I think mostly is IPsec. So in IPsec, you can use IPsec to encrypt the certain data, certain topology or certain information or beneficial information. Okay, using the ACL. So either the data, if no match at all, so go out as a normal data. If match, so the data can be sent as encrypted data. So only the receiving side will know how to decrypt the data. So next one. So ACL types. Here we are showing 3 types of ACL. So first one is the basic ACL. So basic ACL, the ACL number is start from ACL 2000 until ACL 2999. So when you configure the ACL, you not necessarily must start with 2000 or start from 2999. So it depends on you. Depends on the network design actually. So for basic ACL, we only can for each rule, for one rule in the basic ACL, you can only define the parameter source IP. We have many rules. If one, let's say I create the ACL, the basic ACL 2000, and then I include the let's say I want the rules. In the rules, so rules inside will help me to filter or help me to permit some of the end devices by following the IP address. So this source IP. So the parameter can be configured source IP. So if you want to configure more types of parameter, if you just let's say just configure source from source IP, so maybe the lack of flexibility. If you just want to configure from source IP to any one of the other hosts, so you might have to use advanced ACL. The value range starts from 3000 until 3999. So the parameter you can define are source and destination IP, protocol, source and destination, port number. So other than this basic and advanced, we also have layer 2 ACL, which we look into the MAC address. Look into MAC address. You can either declare what is the source MAC address and the destination MAC address. So three forms of ACL can be applied to AR2200 series routers. Parameters for packet filtering vary for each ACL type. So these three different parameters. Next, ACL rule management. Let's say I created a ACL 2000. ACL 2000 is a rule, like a piece of paper. There's a top of it is the name of the rule, and then what are the rules inside. So you can always start with, let's say, rule 5. Rule 5 deny. So this is the action to be taken if the packet match the destination, match the IP address out here. So rule 5 deny source 192.168.1.0. So it will let's say start from the red color one. Okay. Will this source IP match this source IP? So cannot. So because here is start from 172.16.0. So this is 192.168.1. So cannot. So this packet doesn't match the first rule. So if no match, then only we can move into the next one. So rule 10 deny source 192.168.2.0. So I have rule 10. So also this is also a deny rule. So source from this 192.168.2.0.0.0.255. Okay, so is any IP address from this network match the rule? No, so because it starts from, this shows the start IP address 192.168.2.0.2. Okay, something. Okay, behind here 000.255, 000.255. This 255 means what? You convert to binary is 8 ones, 1111, 1111. It indicates that the last 8 bit of the last 8 bits of the packet, okay, can be any number, okay, either 0 or 1. So what you can do now is 255.25, 192.168. Okay. So this means 000 means any IP address match the 192.168.1, only one, because I only want 113. So we'll match. You just have to match the 192.168.1. You can match the rule. Okay. For second rule, say the same thing. 000 means okay. So this one, what is still is 172.16. So the second rule still not match, no match. So the third one, rule 15 deny source 172. Okay. Still will not match. Is it match? Yes. 172.16.0. 172.16.0. Behind here 2.5. This can be any number. So this will match. So when this match the rule, then we take the action deny this. So and then we are no after we carry out the rules. We do our action, take action with the rules, and then we no more continue. There's no match, even though here is no match by previously, so we don't care. Okay. So and then the next one, the traffic coming from 172.16.1.0, and we check again 192.16.1.0, 192.16.2.0. Okay, and then third one 172.16.0.0. Then so we try to match this. Is it match or not? 172.16.1. It is 172.16.0 is 0.0.0.255 means only the last 8 bit can be any number. So in front here 172.16.0. Okay, it's a max. So this will not match the 172.16.1. So this will be move to the next rule to be compared. So the rule 20 will be permit source any IP address will be forwarded.
Sorry, Mr. B.
Yes.
Please, can I understand why there's no match for 172.0.16.0?
Why 172.16.1.0 is permitted?
No, the 0.0.
.0.0 is denied.
Is it not?
Why?
Yeah.
Why is denied?
No match there.
Because this rule.
Yeah.
Yeah.
Or is it that? Do we have to have maybe .1 before it matches? Or .2 or any other?
2? No, you see.
Because the network there, right? Is the network address there, right?
Yes. See, okay, you cannot say in the rule, you say the rule. The rule said rule 5, 10, 15 source 172.16.0.0. Behind is an indicator 0.0.0.255.
Yeah.
Okay, what you can do, what you can get from this rule is, interpret from this is, what are the source IP that match this rule? What is the source IP that match this rule? So, first, you must know how to convert your IP address to binary. Convert IP address to binary. You get 172, maybe 10.1.0.1.0.0.1.0.0.0. Okay. So this is the IP address you put here. The IP address 172.16.0.0.
Sorry, Mr. B, somebody's speaking in the background. I can't hear you.
Sorry. I just mute everyone. Okay, so this is the rule. So what are the source IPs? They will match the rule. So you convert this, the IP address to binary. Then this is what you get. Okay, this binary, and then you also convert the you can say this is a wildcard mask bar, please. So you also can say this is the inverse of your network address. Actually, no. This is the indicator. Just convert to binary. So 2.5 means 1.1.1.1.1.1. So in the end, what do you get? Okay, so since this is an indicator, this means that all the bits on the location 0 on 0, which the indicator is 0, this bit must be follow, must not change, must match. So the first one 1, 0, 0. Okay, I can say all the indicator, all the bits with the indicator 0, so must match. So 1 0 1 0 1 1 0 0 dot 0 0 0 1 space 0, okay, dot, okay, 0 0 dot, okay, last one, the last 8 bits is 1, means that this bit can be either 0 or 1. Okay, so this means what? You convert back to your decimal is 172.16.0 dot something. Okay, this will match the rule. Okay.
Yeah, that's fine. That's fine.
So this is the basic ACL. Okay, so I have a ACL 2000, I create the ACL 2000, and then you create any rule you want. Okay, so rule denies source 192.168 was 192.168.1.0 space 000.255. This say, so what are the source that will be denied? Here, source IP that will be denied is start from 192.168.1.
Yep.
Okay, this one. So for this traffic coming out from here, when coming to the router A will deny all the packet with the source IP 192.168.1 deny. So cannot access the internet. But rule permits source 192.168.1.2. Okay, so this is a permit. 192.168. Okay, .1.0. No, it's .2.0. So .2.0 should be fine. Okay, .2 and .something is okay. So this is permit. So, and then how you apply this ACL is on the interface. Always you should always apply your ACL rule on the in these directions. Always apply in this direction so that you won't go wrong. Means that in the ports on the ports that going out. So going out from the router. So this is the common practice, a better practice if you configure the filter, the ACL on the outbound interface. So this is a command. We have created the ACL. Inside this ACL, we have insert 2 new rules. So you can go to the interface G0. Okay, this one. Okay. Use the traffic filter outbound. Traffic filter means filter the traffic. Which directions? This is outbound. Okay, and then ACL using which ACL? ACL 2000. So for router A, okay, for router A, all the packets are going out to G0 will be checked first. Check for the ACL number, rule and deny. Okay, rule deny the page sourcing attacks, the source IP. Following the source IP here. So this is ACL. So you'll be matched. So 192.168.1.1 will match this rule, will be denied. And then 192.168.2 will be permit. Okay. So this is basic ACL. In basic ACL, we can just define the source IP address. So if you want to define more, use the advanced ACL. So advanced ACL, you can further improve, you can further define more parameters such as the protocol. Okay, then also included the source IP, destination IP. Okay, and then destination IP. Okay, and then also the destination ports equal to what are the ports. Okay, then let's say how this rule is being matched. So this advanced ACL start with 3000. Actually, it doesn't necessarily must start with ACL 3000. You can start with ACL 3999, or you can start with ACL 3100. Also can. It doesn't matter, but make sure you know each of these different ACL is for what purpose. You create this. So you create this. In the example here, I create the ACL 3000, and then the rule, you can put rule, then deny. Okay? Deny about what? If you capture TCP source IP 192.168.1.0, okay, and then 000.255 means, what does this mean? What are the source IP address that will match this the source IP here? All it means, see, 000.255 means the first one, 192.168.1 will remain. Okay, it will change once my pen. Okay, so the last one, 255, means that the last digit, it can be 0 until 255, either one. Okay. Then for destination, you can put the IP address of the FTP server of the server. Okay, so what happened? Must match 0000. Okay, so all must match. So this this 4 zeros.0.0.0 you also can configure as 01 for today. So the destination, and then the destination port 21. This is FTP. So means that this the source IP traffic with source IP 192.168.1.0. Okay, this one. Okay, this being denied, cannot go through. Okay, so means that the host A still can access the private server. So and then rule deny IP. Okay, this time is using IP source 192.168.2.0. Okay, 2.2.0 means this will join. So next one. Okay, source IP. Then any, and destination 172.16.10.2 0000, or just put a 0 also can. So this means that deny all the traffic that source from 192.168.8, 68.2, and then destination 47. So 172.16.10.2. So this will be denied. So this ACL, we can put in the traffic filter. Traffic filter this time is inbound ACL 3000, because this time we use this interface as the main interface. So what you need to do is this. Traffic inbound, of course, I remember I mentioned, if you're sending here, this is your inbound, this is your outbound. Coming in and going out. Coming in is inbound, going out is outbound. So depending on which way of traffic you want to filter. So traffic filter, inbound, outbound, and then ACL 3000. Following this. So, and then you can validate the configurations. Always display ACL 3000 to check whether these two rules is running, with this rule is running, and then each of the rule is being matched for 5 times. So you will record here ACL steps 3 times. 2, 5. Okay, so advanced ACL rules define the range of 3000 to 399 to add complexity due to the number of parameters used for filtering. So, okay, this one, net address group 1. So this is what we done the net yesterday. So when this router is the gateway, to translate the private IP to public IP. Okay, private IP to public IP. So this is the next. We have 2 different address group, public IP address group. So both okay, create 2 ACL, ACL 2000 and ACL 2001. So ACL 2000 is to permit source 192.167.0. So means that source IP packet with this source IP will be, let's say, permit if start with the 192.168.2. Here. Okay, so again 0.0.255 means that same. Okay. So you can create another one, ACL 2001. This one is rule permit source 192.168.2. 0.0.255. So interface, after you created this, on the interface you apply both the public rule with the ACL. So the first one net is the net outbound. So net outbound define that. So basic ACL 2000 is for network address group 1. Okay. Next one is also outbound. So it's 2001 versus in the net outbound 2001, ACL 2001 is mean, and then the address group will be 2. So if you match 2000, you are translated to address group 1, you are match 3. Okay, or if you match 2001, you'll be directed to 192.16 using will be translate. Actually, the private IP will translate using this address group 2. So this is how you can apply the NAT for interested traffic. You just want to filter out this traffic, and then what you want to do next. So the advanced access control list is capable of filtering traffic based on which attributes?
Source and destination IP.
Source and destination IP address.
Port numbers.
Port numbers.
Protocols, I guess.
Protocol numbers. Okay. So next one. Once an ACL rule is matched to the condition, what action is taken? Okay.
The action of the rule will be implemented, isn't it?
Yeah, the action either is permit or deny. Okay, either permit or deny. Okay. So let's do this. Okay. Before I go on, let me add on something here. You do notice that you had the rule 5, rule 10, rule 15, rule 20, but when you're declaring the rule, it doesn't have any number here. Rule 1, rule 1. No. So why we have this? Yeah, actually this is 2. It's a sequence number. If you don't configure the sequence number, you always start with 5. Okay, 5, 10, 15, 20, then keep on updating and keep on save. Okay, so keep on this 5, 10, 15. You can change this actually, change to 3, 6, 9, 12 also can. But so this will be according because the rule will be sorted in ascending from small to higher rules. So if you don't configure any rule, the system will automatically help you to put 5 and then 10. Okay. So this one. Okay. So do everyone already get ready with this topology? So is everyone already get ready with this? Okay. Okay, based on the configuration on the setting I put on this topology, I have a network 10.1.10.0.0.0/24. Okay, this is this is 2 networks, 2 private networks is also can. So here I have PC1, PC2, and the router 2. Okay, so these are the IP address. PC1 is 10.0.0.1.2 and 3. Okay. And then this is just we do this just a layer 2 switch, just a dumb switch. Okay. Then we connect to this interface. This another host in this network. So the IP address will be 10.0.0. Okay. 254. Okay, and then for external side, okay, I have this IP address, 192.168.0.0/24. So PC3 is .1, .3, .2, and .254. Okay, so below here are the configurations for R1 and R2. This R1, this R2. So these are the configurations. So for R1, sysname, and then go to the port, the interface. So and then configure the IP address 10.0.0.254/24, and also link my PN. Another side. Okay, sorry for another side. And here G1 will be IP address 192.168.0.254. Okay, so you can just copy the IP address, and then R1 system view, paste. Okay, so these are just steps to configure IP address on the interface. So it's you should be familiar with this in configuring IP address on interface. So we just copy and paste this. So for R2 also the same, but here and configure this one. R2, because R2 only have one interface, I need to configure with the IP address. Okay, and then this one, G0, okay. So, static route, let's say in our PC1, what we have? We have IP address, subnet mask, and your gateway to 10.0.0.254. PC2 also have, right? gateway 10.0.0.254. Same, similar. So does your R2. We need to give R2 a gateway. So for gateway, we just have to configure IP static route, a default route for the router 2. IP route static 0000 space /0. Next hop 10.0.0.254. So copy this, and then go to R2, quit, paste, enter. So done. So now for configuring the IP address on routers. So for PC3, PC4, and server 1, the IP address and the subnet mask and the gateway is already done configured. So what you need to do now is PC1 can ping PC3. Let's say PC1 can ping all the device. Okay, from the other side, let's say PC3 can ping everyone. So please, you can start by testing this. We do make sure of this. So go to PC1 IP 192.168.0.1. Okay, it should be a success because we have the gateway. Okay. So and then next one 192.168.0.2. Okay, success. Another 1.3, so which is server 1. 192.168.0.3. 254. Okay, success also. So I go to PC3. Let's say I have to ping PC2 and PC2 and R2. Ping 10.0.0.2. Yeah, success. So another one is .3, which is a R2. Okay. I should go to R2, try to ping someone, ping 192.168.0.1. Yeah, success. C3 again. Yes, success. Okay. So let's say the communications now between both sides, between both ends to each other is up. Is no issue. It works. It works. So now when to configure some. Let's start with some basic ACL. Just configure based on the source IP address. So here I have a command ACL 2000. Then let's say R1. R1 is the gateway that analyze and filter the traffic. So R1 can just put ACL space. Let's say ACL. And question mark. I have basic ACL, advanced ACL, and layer 2 ACL. Okay, so I can just start with 2000. Then the ACL, the list is already created. Now I want to put some rule inside this list, this ACL. So I have the rule deny source. 10.0.0.0.0.0.255. Okay. Let's take this, copy. Oh yeah, I'm still inside the ACL view. So paste. So display this or display ACL 2000. ACL static 5. Just now here I don't put any blue sequence number. No. So the system will have automatically help me put the 5. Rule 5, deny source 10.0.0.0.0.0.255. Any source IP, okay? Source IP 10.0.0, okay? Will be denied. Means the packet will be dropped. So next one is the interface G001 G1 on this interface. So traffic filter outbound is ACL 2000. So traffic filter, you want to apply a traffic filter on G1, and then outbound, the traffic direction is out. Okay, these directions. And then ACL using what? What are the rules? ACL you can use to compare, which is ACL 2000. So this you apply on the this, copy the rules, okay, paste. Okay, this paste, okay, it already existed. Let's say the next one you have to configure is apply the traffic filter on the G1. Okay, paste, enter. So now the effect is already taken. So display this. Okay, so this is success. The traffic filter outbound ACL. So now PC1 and ping PC4 is server 1 but fail. So then we ping PC3. Okay, so cannot all packet loss because all the packets sent to packet source from 10.0.0.1. Okay, it will all match this rule, which is deny. Okay, so how about I change some of the rules? Let's say traffic filter outbound ACL. Oh no, sorry. I should just go into the ACL 2000. Display this. Let's put the rule. Let's say rule 4. I permit 10.0.0.0.0.0.255. Display this. Rule 5 permit. Oh, I should put a source. Rule 4 permit source. Display this. Yes. Okay. So means that now PC1 can ping PC3 again. Okay. So R2 P192.168.0.3.
The ping. The ping is wrong.
Yes, 192.168.0.3. Yes, success. So you can see on the R1, I tried to use the smaller sequence number. I tried to temporarily bypass the rule 5 because maybe sometimes I want to allow some of the IP addresses or to allow some of my the end devices with certain range of IP address to go to the internet or go to the another network. So I can temporarily use this rule. So temporary permits, and then after I done, I want to stop them from continuing to access. So I can just undo rule 4, and then display this. The rule is gone. So that's why when we just define the rule, create the rule, but without putting the sequence number, the system will automatically help you put the sequence number in 5, 10, in the step of 5 actually. So that in future you want to do some interventions, maybe you can put it in you can use the sequence number in between this. Okay. So this is a basic. So basic ACL just can define the parameter source IP address only. So if you want to more precise, so you better just or let's see one more. Let's create one more rule. Let's say rule 4 permit 10.0.0. Let's say .2. Then put 0. Oh, again, I still always forgot about the source. Source, enter, display this. This one, what do we mean by this? Means that now only PC2 10.0.0.2 can be. Okay, should be 192.168.0.1. Success. All the other. That fail because R1 configure 0 means 0.0.0.0, so means must match all the bits here. If you match all the bits here in this IP address, means that the source IP address is 10.0.0.2. Okay. So for now, quit. Go to the interface. Yes.
When permitting rule 4, when you ping piece 1, it initially timed out, then before it picked up, what happened?
Again, initially again.
When you use the bypass to
this one, rule 4.
Use that, and then you ping from PC1 to 192.168.0.1.
By using this, this rule,
yeah. No, the initial rule. Apart from, yeah.
The initial one. Without this.
The one before this. The one before that.
The one before that. Okay, the one ACL 2000.
No, it's just up there. Yeah.
Okay, maybe I just put rule 3 permit source 10.0.0.0.0.2.5.
Yes.
Wait, this. Okay.
So when I ping from PC1 to 192.168.0.1, it initially timed that before it picked up. Where was that?
It initially timed out. Means like
it said request timeout and then began to yeah.
So what do you mean? You mean why request timeout?
Yeah.
Why? Because on PC1 I send to the gateway. So I send my ping to the gateway to R1. R1 said to send what? Send an ARP request to find out what is the MAC address of the PC3.
Oh, ARP. Okay.
In that waiting moment, PC1 thought that too long. I waiting this ping request. I send out the time limit. To wait for the ping reply is finished. So I consider this request time out done.
Okay. So to capture that, if I use the Wireshark, I would have seen the ARP request, right?
Yes, ARP request sent out from R1. Try to look for PC3. Yes.
Okay, thank you.
Okay, so means that this request out not so important as long as you can be this is a result what we want to see again. Okay. Okay. So these are the basic ACL. Now I go back to G1. Display this. So I want to remove this traffic filter. Okay, undo traffic filter. LT filter. About enter display this. Now got no more any filter. So now let's go to do the advanced ACL. So from here, you see, I created the advanced ACL 3000. So you can see the first rule. I didn't put the sequence number. I just put rule deny IP. So this is the protocol. Protocol. Okay, it's a protocol. And then this is the source IP address, source IP address. Destination. Okay, if you want more, you can have also include the destination ports. Okay, you put destination IP address. Okay, this is the wildcard or the matching, the wildcard bits, and then the destination ports equal to a port number or a name also can. So that depends. Means this one source from what? Because we cannot decide on source. We can also actually you can also define the source port, but that is not so accurate. That is not so big effect, not so effective. Why? Because when I say when a PC, when a host are trying to access to a server, maybe FTP server, so of course it can the destination IP is the destination port is the, let's say, the IP address of the server, and it's FTP. The destination port is 21. But on the header, the source IP, of course, is the IP address of the host, but the port number it can always change. Any port number of the private port range. So we don't define it here. So for sometimes that is also depends on situation. You also can make an experiment with this. So now let's see. Let's create the first rule. See, click from this ACL 3000. Yes, I created the ACL 3000, the advanced ACL. So the first rule is just put rule deny space IP, or just let you see deny question mark. I can put GIE, ICMP, IGMP, IP in IP, OSPF, TCP, and UDP. So the most more common we are using are the ICMP, IP, okay, TCP and UDP. So rule deny IP source from 10.0.0.1 space 0. This is the PC1. Then destination. Oh, I just put a question mark. Let's see what you have. You can put destination, DSCP, fragment, 9 time range. So there is no source port, isn't there? There's no port for you. Source and destinations. I think this is because of this TCP. We just continue first. So destination 192.168.0.1 space 0. Okay. All this means when you put a 0, means the IP address at the front. It means the IP address of a host, of one host. Okay, enter. So I created the rule, and I go back to my interface G1, and I put traffic filter outbound. Well, say ACL 3000. Okay. So what I cannot do is, if I want to ping from PC1 to PC3, it will fail. So that's right, PC1 ping PC3. Request timeout, request timeout, request timeout. Okay. Well, I get 5 requests timeout because I sent 5 ping requests. From here, I display ACL 3000. Display ACL 3000. Okay. This root 5 deny IP source, destination is, and there are 5 match. 5 match because there are 5 ping requests match the rule and being denied. So next one. So can I ping others? PC1 I will ping PC4 and .2 192.168.0.2. Yes, success. So this is more flexible when you can define the destinations IP address. So the next rule is rule 10 permit ICMP source from PC 10.0.3. This is R2. Okay. IP source from R2 10.0.3. 0 means this is the host IP address. Destination 192.168.0.3. This is the server. Okay, so this rule permit means is allowed to ping. So R1. So I just go into the ACL 3000, then paste, put in the rule, display this. Okay, the rule is inside, means it's already a success. Success. So the traffic filter in the phase of G1 will automatically use that rule, apply that rule. So how can we know if the rule is applied? Let's see. ICMP source. .3 go to destination .3. This one. 192.168.0.3. Okay. Success. 5 ping packet. Ping request success. So I display ACL 3000. I can see because there are 5 ping requests that match the rule and we permit 5 matches. Okay, and then the last one here we can see rule 15 deny TCP source 10.0.3 0 destination 192.168.0.3 0 and then destination port. Okay, this is FTP. Destination port FTP. So let me open the server FTP features FTP and try to browse. This is the desktop. Okay, so start. Okay, so because I want to use the R2 as the FTP plan, so FTP 192.168.0.3. No username, no password, EIR. Yes, correct. This is my local folder. I use the local folder as a simulate a FTP server. Okay, so then I quit from this. So once I apply this rule, once I apply this rule, so is that the FTP will block. Okay, so the display this check. Yes. Now for R2, I try to FTP again. So there's no response. Okay. So, but can I ping? Yes, I still can ping because I have the rule. This one. Okay, commit ICMP source. Okay, so until here is our experiment for this our lab for ACL. So there are many more you can do, many more commands you can do it during you do it on your own. You can keep on repeating, keep on try to different combinations of commands. Okay, IP, ICMP, TCP, UDP, GRE. You can keep on changing this. Okay. Then advanced. So for the okay, that's all. So do you have any questions regarding ACL? Because here I just show you how to use the traffic filter. So if you want to use it to filtering the interested traffic, I will talk about this in the next in IPsec VPN. So here, until here is our ACL. So again, so inside the exam, how they will ask you is this. Let's say it's question like this. What is the IP address? What is the IP address will match this rule? So he will give you a rule and then give a multiple choice for, let's say, 4 IP address. Then we'll ask you which IP address will match the rule. Then you need to find out. But here, it's very easy. You just know that 0.0.0 is an indicator. You know that the first 3, 172.168.0, confirm is fixed. So only the last, okay, the last one, okay. Only the last one can be any number. So when you see see from the answer, you start with 172.16.0, that is correct. So but always, this is very easy, but in exam not so easy. Maybe you will put something here. Let's say I put 240. I will put 240 right here. So what are the IP address that will match this rule? Okay. So you don't need to feel feel nervous. So just copy down this 172.168.0.0. You know that. Okay, this is the IP address. You can convert to binary, or you can just know that from here, this is 0. This is 0. Then you know that this 172 is fixed. The third one, the octet. So it's also 0. You know that this must match 0. So behind here 255, don't care behind. Okay, you know that behind here don't care. Then this is 0, and this is 172. Okay, so here 240. We just change it 240 to binary 1111. This is it. So what you get 1111 is that these 4 bits are either 0 or 1. So this is the IP address that will match this rule. So you must know from the given answers, multiple choice, maybe 4 answers, 4 choices. You must know how to convert the IP address to binary. Okay. Okay. So I think we can take a break from here. When I say break time, So we continue. Let's take a 10 minutes break. We continue at 10:30 a.m. So in the meantime, if you do have any questions, you can always post in the WhatsApp group.
Is anybody there?
Hey, so sorry.
Sorry, Mr. Bay.
Yes, yes.
I had a complaint there. Did you see it?
Yes. Yes, I saw it now. Just now I away for something to handle something issue. Okay, so cannot ping from R2. Let's say R2. R2 after applying the rule 10, permit ICMP source, you cannot ping from R2 after. Before you apply, you can ping. After apply, you cannot ping.
I just observed something. Sorry. 192.168.0.3. Yeah. The timing out.
Let's see. This is my R2. I display ACL 3000. Oh, I should be R1.
R1. Yeah, R1.
Display ACL 3000. So, I better go into the ACL 3000. Display this. This is more accurate. So, you have the same command.
Yeah.
Rule 5 rule 10 permits.
ICMP source 10.0.0.3 0 destination 192.168.0.30.
How about this one? The first rule 5. Do you have rule 5 or you don't have?
IP source
also
10.0.0.1 0 destination 192.168.0.0.1.
Correct. Okay. So, but now you cannot ping. Still cannot ping. How about you go to your interface G00Y. Display this on R1. Yes, R1, because the configuration we are actually all the ACL configuration we are done on the R1.
G0001. What am I looking out for?
So you go into and then display this. Then you check your configuration on the interface.
I'm only seeing the IP address.
IP address.
192.168.0.254.
There is no traffic filter outbound. Nothing.
No.
Nothing. If nothing, you should be able to ping. You should be able to ping. If nothing, let's say I undo the traffic filter. Copy. Display this. So no more that PR2. I try to ping 192.168.0.3. Request timeout. No, okay, it works. That takes some time.
I think something's wrong with mine. Maybe I have to check it later.
Can you ping let's say ping PC3.1 192.168.0.1. Ping the other. .1, .2, .3.
No,
cannot. Maybe it takes some time. Or can your PC1 ping PC3. Go to your PC1, try to ping PC3. PC ping to PC. C cannot. Because you are not applying any IP, any traffic filter. You should be able to ping.
PC1 to
PC3 at 192.168.0.1. 192.168.0.1.
Sorry, did you say PC2? PC1 to PC2?
PC1 to PC3.
Oh, to PC3. Okay. So
168.0.1.
Yeah, it's pinging.
Okay, success. Can ping,
Yeah.
You sure?
Yeah.
It sure means the R1 is okay, but why your R2 cannot ping? If your R2 have the IP address, R2 IP address is this, and
Yeah.
have you configured the this one static route for your R2? Your R2 display IP routing table. Do you have this static route for as a default route? Do you have this?
On R2. On R2?
Yes, R2.
Okay.
You go into R2 display IP routing table.
Hold on. Display IP route. No.
No.
Only 127 and 127.
Yes. If no, let's say if you got no default routes, and then let's say your R2 want to ping 192.168.0.0. Then you try to find at the routing table. There's no 192.168. He cannot even send out the ping request.
That's right. That's true.
So you have to put a default route. As this default route is like it's just like a gateway for the router.
Yeah.
For your PC, you just configure at the gateway.
Yeah.
The gateway. But for a router or for the switch, you have to configure the default routes.
Yeah. I think that is where the problem is.
Yes. Okay. So you configure the default route. I'm sure that you will be able to ping.
It's saying IP route static already exists.
Are you sure?
Yeah, it's saying IP route static.
You don't see this. You didn't see this in the.
Yeah, I didn't see that. Maybe is there any way to erase the initial configuration from R2 for the route static? It is already existing.
You go to System View.
System View.
And then display this.
Display this.
Do you see this? The route static.
Nothing is there.
You don't see this.
Yeah, nothing is there.
So then it means that you can configure this on your R2 type IP route static.
Yeah, and if I try to do that, it complains that it already exists.
It already exists. Okay.
Anyway, we can continue the class. Maybe we do that later.
Okay, sure.
So we don't spend too much time.
Okay.
I think there's something wrong with that route. My configuration.
Yeah. Maybe you try display current configurations and see what you have. Maybe your IP address, on your port, your physical IP address, correct or not. If everything you follow the command I put on below, it will be you should be success. Okay. Okay. So now we continue to the next topic. Let's see. Next topic we're going to AAA. Okay, AAA. Okay. So this is also one of the, let's say, security features in network when we talk about AAA. Okay. So AAA defines a security architecture that is comprised of three functions referred to: authentication, authorization, and accounting. Each of these functions represent a modular component which can be applied as component of the security framework, implemented by an enterprise and often managed through the use of client-server-based protocols such as Radius and Huawei Type-X. Implementation of the AAA architecture as a solution for enhanced functionality is introduced to reinforce the overall security framework. So I will explain the scheme of the AAA security architecture, and we can try to configure some authentication and authorization schemes. So AAA application, where we apply the AAA, in what scenario we apply AAA? Okay, what's it network? Okay, so AAA enable the authentication, authorization, accounting. So you must remember these three things, huh? And of user attempting to access destination network resources. So, oops, where's my pen? Okay, so this is the client. Hawaii domain is a client, huh? The client. And then this is the destination network. Yeah. So the client from the destination network try to access to this destination network the resources in this network. Huh? It can be a PC, it can be a server, it can be a storage. So that depends. But before that, all of that need to go through the NAS. Actually, this is not the network attached storage. This is called network authentication server. Or you should say network access server. Network access server. Okay, so this router can be a network access server. It will try to validate whether the user coming in, okay, want to come in, allow or not, try to authenticate, authorize, and do the accounting. So the router can carry out these three functions. Okay, the router can do authentication and authorization locally. The router can do these two functions, but the router must depend on the server to do accounting. Also, the router can totally depend on the server to do all the authentication, authorization, and accounting. Okay, why? Later I explain to you. So let's see the first one. Authentication. So user access is managed based on an authentication scheme. Okay, this scheme can be locally or can be remote. Okay, let's say locally. Still remember in router, when we configure the AAA for local user Huawei password cipher 123. This is local authentication, local scheme. So when the host try to access, let's say I try to telnet to this router. Okay, so the router as the authentications, you ask for the username and passwords. Username and password. As a host A need to send his username and the correct password 5123 to the router. Router take the username and password, compare with the records, and then either success or failure. That's all. So success authentication, again, authentication means can you come in or not? Are you coming in? Can you come in or not? So after you can come in, then we do authorization. What you can do, or before you come in, also mean that when you can come in, what are the period you can come in. So let's say for this wholesale group staff can access. So what you can access? You can access public group, public device, which is example server B. So the time you can access is between 9 to 6, and then the user privilege is 2. Okay. If another example here is user. If your user are admins, you can access the public device between 9 to 6, privilege 15. Or if you are user, you can access the private device, private group, and from between 9 to 12, privilege also 15. So depends. So what you can access depends on who are you, what you can access. So when you can access and what is your privilege, what you can do. So this can be done by this authorization can be done by the router itself, or can be held by a radius or polytechnic server. So, but for accounting, the router must depend on the server. Why? Because accounting means that what you have done, when you come in, when you go out, what you have done, what you download, upload, what you have changed, what changes you have made. All this, if record means it's a log. So router, because the storage, the storage size on the router on the network devices usually is very small. It will not enough for you to keep on accumulate all the records, all the log file. So accounting, the router must have depends on the radio server or polytechnic server to do the logging. So it record this host A, login time, and then the uptime, and then upload bandwidth, download bandwidth, what you have done. So I record everything here on the log file in the server. Your server, we can install, we can put in so many, a lot of storage, hard disk or solid state drive. We can put a lot of this storage into the server. So we prefer using the radius, or you should say the router, or let's say the router, the switches, all the network devices depends on the radius server to do the accounting. Next, AAA domains. So different scheme can be applied to user in different domain. Okay, schemes. We have authentication schemes. We can create server authentication schemes. We can create server authorization scheme. We also can create server accounting scheme. Oops, what happened? Someone tried to share your screen. Oops. Sorry, who's trying to share the screen?
I think it's Lucky. Lucky is trying to share his screen.
Okay.
Lucky,
do you see my screen, or do you see my screen now, or Lucky screen?
Yeah, showing
initialize your
initialize.
screen. Initialize. That is Lucky. That should be Lucky ICT. You should try on sharing his screen.
Yeah.
Yeah, let me see. Now can I do that? Stop participant sharing. Okay, let me see. Is this? Okay, I try to stop participant sharing. It seems.
Is it not?
Who's trying to share the screen? Oh, Lucky. I see.
Yeah.
But you should be hearing us now. It's Lucky. They're hearing us now.
I think he mistakenly touched something.
Yeah, I think so. Yeah.
So Lucky mistakenly shared your screen.
So Lucky, are you there? I think it's not there. Maybe he's trying to installing. But why he want to install the Zoom? Since
hearing us, that's what I'm saying.
Since he already joined the meeting. Never mind. Can you? No, just mine. You see Lucky's screen for now. So
if it's not around, we have to.
Or maybe I put him in the waiting room. Let's see. Okay. Let me stop to share. See Lucky screen stop participation. Okay. Okay, already stopped the sharing. So let me share my screen again.
Okay.
Okay, now you can do. Okay, let's continue. So again, so all the routers also can create several authentication schemes. So many type of schemes. So on these all schemes, you will mention, okay, it's a scheme, or it's an authentication scheme, is a local or radius or whitetext or all three or both or three or two. One options, two options, or three options. So authorization and accounting also the same. So but for accounting, you must have use the whitetext or the radius. So there are different kinds of schemes you can create. And then, okay, for domains, I can create different domains. And these different domains, you can apply different kind of schemes in these different domains. So depends on your network design. So different scheme can be applied to users in different domains. Maybe let's say I'm at partner domain. Partner domain, I use, let's say I use local authentications, and then also local authorization and let's say remote radius accounting. Okay. But for Huawei, for Huawei domain, Authenticator will use the radius authentication, radius authorization, and also radius accounting. So depends. Yeah. So there's the maximum number of domains in one router you can create is you can have is 32. Okay, but there's already two domains is already exists, which is the default domain and the default admin domain. So these two domains you can change the schemes, change the scheme, but you cannot destroy, you cannot delete the domains. So means that you can only create another 30 domains. That another 30 domains you can create, you can delete. Of course, you can change the schemes also. Okay, so local configuration, AAA local configurations. So AAS, local user Huawei password cipher. Hello 123. This is the password. Remember, this is the password. And then, okay, I want to create an authentication scheme. Let's say authentication scheme of one. So now inside of one, you have to set authentication mode, local, or radius, space whitetext, or just whitetext, or just radius, or just a local. So depends. It means that you can create several different schemes, and then quit. And then you create authorization scheme. Put a name of two. And then authorization modes can be local, radius, or whitetext, or any combination of these three. And then quit. So now I have one authentication scheme and one authorization scheme. So I create a domain Huawei. So authentication scheme, I want to use of one. Authorization scheme, I want to use of two. Okay. So next. So and then you create the domain, you display domain name Huawei. And then, okay, these are the statistics. Huawei, domain state active, authentication scheme name of one, accounting scheme name or default means no. Authorization scheme name of two. Okay, so later you also can create, you can see radius server template, Huawei server template, all these. Or you don't look so deep here. So local AAA authentication scheme are associated with individual domains. Yeah. So all the schemes are associated. All the the domains can have their own the schemes. Okay. Then schemes. What else, okay, this one. One thing you need to, they will appear in the exam is they will ask. So if here I put authentication scheme of what? And then again, maybe I created another authentication scheme of 3. So below here, I put another command, authentication scheme of 3. So what happened right here? Authentication scheme of 1, and below again I put authentication scheme of 3. So what actually happened is our of 3 will override of 1. Understand? Means that in one domain you can only have one authentication scheme, one authorization scheme, one accounting scheme. You cannot say I want both of 1 of 3 together. No. Okay, so it will override. Okay, you put another one. This will ask in the exam. Okay. So which 2 AAA schemes are supported when configuring VRP to support the local modes? Local mode means we create the username using the local user, Huawei, password, cipher 123. These are local authentications. And then local authorization, you put the local user service type. Authorized. This user can access to what service? Authorizations. Or you cannot do accounting. So which 2 AAA schemes are supported? So in local, router only support the authentication and authorization scheme. So if there is no domain is defined for user, what action is taken? No domain means you go to default domain. So where is default domain? Let's see. So display current configurations. Here it is. Default domain, the default and default admin domains. Okay, these 2. Okay, next. Okay, so that's all for this AAA. Or maybe I also can show you some of the configurations. Let me show you some configuration using the same topology. So just show you here. Okay, I have AAA. Or not. Let me just create a authentication scheme. Authentication. Oh, I should go into the AAA first. Everything I need to do in AAA. So authentication scheme. Authentication scheme. I put authent1. Enter. So authentication modes. Question mark. I can have none. Okay. Hoitag X, local and radius. So I can put radius. And then I can put some more. I can put local. I put some more. Okay, I also can put Hoitag X, but it's not. Just put radius and local. Okay. So, and then about authorization. Authorization. Oh no, I should quit from this first. Quit. Authorization scheme. Then author 1. So authorization modes. Question mark. I can have Hoitag X if authenticated or this. Let's put the Hoitag X. Can I put some more? Local. Some more. It's not, huh? Okay. Now quick one. This then domain. Okay, I create domain Huawei. Okay, so authentication scheme, I have authent1. Okay, then authorization scheme, author1. Okay, then quits. Click on this. So display, display domain name Huawei. And this is my domain name, active of authent1, author1. Let's try to do one more authentication scheme, authent2. Okay, authentication modes, local, and quits. So I go to domain Huawei, and then authentication scheme. I want to change to authent2. Authent2. Question mark. No more, only one. So now enter. So display this. Nothing. Never mind. Just display domain name Huawei. So now you can see my authentication scheme changed to authent2. Means that I only can have one authentication scheme, one account, one authorization scheme. So what about the accounting? Can I do it? Accounting scheme. I say account one. So accounting, what I have? Accounting modes. You see, only Huawei TechX and Radius. There's no local, okay, for accounting. Let's say Radius. Radius. Oh, sorry. Radius. Great. So domain Huawei. Accounting scheme. Account one. Okay, display. Domain name Huawei. Oops. Display domain name Huawei. Now I have accounting scheme, account one. Okay, so on about how to set up the configuration for Radius server or Huawei TechX server. So we will not discuss in this training. Okay. You always can refer to the headex file to find out how to configure. So example for Radius server in the market is can use your Windows server. Can be a Windows server have a features as to you can enable the features to support Radius server so that you can use your AD account to authenticate in the network devices. Okay. So let's see the next topic. Next topic will be the VPN. So we're doing for IPsec VPN. Okay, oops, for this. Let me close this. Save. We need to, I'll share you the topology. So I have two topology for you. Okay, so Dr. Ba, you have fixed the problem by resetting R2IP and the route static config. Okay, good. Okay, so I share the IPsec VPN topology in the WhatsApp group. Please download this and extract and start run the topology and start all the device. Okay. This is the okay. So since that you see, I can close the left panel of my NSV. The shortcut key to close the left panel is the Ctrl L. Press Ctrl L to close the left panel. You press the Control key to open the left panel again. Okay. So from here, so remember, start all the device. So start, we let the device to boot up, take the time to boot up, and then we go through the slides, while we're waiting the device to boot up. So now it's starting. Okay. Okay, let's go into this. Securing data of IPsec VPN. So if you see a lot of advertisement in the internet, maybe you are going into Facebook or YouTube, you always see some advertisement. They are advertising, they are providing a VPN service in the for you. You can subscribe the VPN service maybe for few months or 1 year. So the VPN, it allows you to connect to maybe different countries. Securing data. So this IPsec VPN. So if in enterprise, what do we have? Enterprise VPN. VPN means a virtual private network, and IPsec is one of the kind of the VPN. So before that, let me explain how do we use the VPN? Okay. Why we want a VPN? Okay, let's see. I can just use this topology as an example. So you see, my PC1. Let's say this is my router, and my HQ. This is my branch router, and then this is the internet, the public network. Then this is my private network, okay, so that makes it more clear. So this is my private network, so this is my router, this interface G1 is inside the private. So so my router G1 is inside the private network. And then from the other side, this one, internet. Okay. So for my router G0 is in the public. My branch router G0 also in the public. So what happened? Why do we want you to have the VPN? Okay, why do I want to have a VPN? Let's see here. Okay, do you think from PC1, I can ping PC2? Can PC1 ping PC2? Let's say PC1 IP address is 10.0.0.1. Can I straight in my PC to open the command prompt? Ping 192.168.0.1. Can I or not? Can I do this? Anyone? Can or not?
Hello, Mr. Ben.
Hello? Yes.
I'm having a bit of network challenge. Were you saying something?
Okay. Do you see my topology here?
Yes, yes.
Okay, let's say in the middle and here is the internet. So on the left and the right is the private network. Can my PC in the private network PC1 with the IP address 10.0.0.1 ping my PC2 in another private network with the private IP 192.168.0.1? Can or not? Can ping or not? Let's say in live network, in real network. Can I open let's say in your laptop, can you open a command prompt in your laptop and then you ping a PC at your home? Can you do that using the private IP?
From what I'm seeing here, there's an IP route static, right, from both ends.
No. It is just a simulator. Just represent something. Represent the internet. This router just represent the internet.
Oh,
I mean, real life network. Why do we need a VPN? Why do we want VPN?
Oh.
So I ask you, can you at your office, let's say you have a server at your home, right? Another PC at your home. Can you, from inside your office, you use the private IP of your PC at your home? Now, inside your office, you ping that IP. Can you do that?
Not until I try.
Without the VPN, it won't be possible. It will be possible to ping without the VPN.
Oh, I should say, now you at your office. What IP address you have? What is your IP address?
PC1 cannot ping PC2.
Yeah, PC1 cannot ping PC. I know in this topology, yes. But do you have what is your IP address? Huh? What is the IP address you have? What is your IP address?
My IP address?
Yes, your IP address. You guys open the command prompt and then IP config. So this is my IP address.
Okay, my IP address is 192.168.15.167.
In 192.168.
Mine is 192.168.15.167.
Okay, I have to ping your IP. Can I ping your IP?
15.167.
Yeah.
Yes. Ping.
Why I cannot ping? Why? Why? Why I cannot ping?
In time out.
I'm in Malaysia here. You are in Nigeria. I know what is your IP address, but I cannot ping.
I took address translation first.
Address translation. I know what is your IP address already. So
Hello?
why let's say I don't want translation. I don't want to know what is your private IP. I just want to ping. You see this private IP and the ping to you. Can I? Means I want to ping private IP. I use my private IP to ping your private IP over the but over the public, over the internet.
I don't think that's possible, is it? It shouldn't be because you need to be granted permissions at all levels, isn't it?
Granted the permissions, such as, okay, the routers, all the routers that help to do the packet forwarding in the public network will never forward the private IP.
IPs. Private IPs are not routable. They are not routable over the public network.
Okay.
Yes, you are right. Private IP are not routable in public.
Are not routable over the public network.
Yes, you are right.
Okay. Okay.
So what should I do? I want to ping using my private IP. I just want to ping your private IP. Can I? So in normal circumstances, you cannot do that.
Yeah, my network is breaking.
It's not. You cannot do that. But this is where we have VPN. Can you understand? Virtually private network. Physically, we are different network. But virtually, we can be the same network. Can you understand this? VPN. Okay, so we can use VPN to connect my private network and your private network together. Even though you cannot say that, or you cannot say that my network address is same as your network address. No, we can have two different private networks, but can join together, just like one router to one router. Not one router to one router, is we are joined to the same router. The concept is like this. Okay, I have a router, and then I'm here, you are here. So right here, my IP address is 10.1.1.86. There, your IP address is 192.168.15.167. So if there's a router, this is a router. VPN makes us are just like we are connecting to the same router. Okay, so that if I ping your private IP in 192.168.15.167. So this one, okay. So this ping packet sent to the router. Router read the private IP. Okay, destination or 192.168. This network I know where I see. This is another direct connected to me. Direct network connected to me. So I can just forwards. Okay or not? So virtually private. So at here, maybe at here you are connected to the internet or virtually. Okay, but physically you actually pass through the public network. All your packets actually pass through the public network. So what happened? Why the routers inside the public network never see all these private IPs? Why? Why? So that's what we want to learn here. IP side VPN. So actually all the VPN works almost the same way. What they do? What actually they do to your packet? It should send this packet. What they do, what they have done on the packets. Let's see. So I will explain the basic principle of IPsec security architecture, and I will show you a demo. I already sent you the configurations, the topology, the configurations. You can do it. So later I will show you, and I will point out. I use the Wireshark to capture the packets and then show you what the VPN has done to your packets. Okay. So IPsec VPN application, where do we apply the IPsec VPN? So IPsec VPN, we can apply gateway to gateway. Means that we can combine two networks, connect together, just like a virtually private network, gateway to gateway. We also have something we call the SSL VPN, is for host to a gateway. It's just like you want to do remote, you want to work from home. So you want to access, some network resource in your office. So you can use the SSL VPN, Open VPN, such as this host for your PC as a host. You can connect to your gateway in your office. So for this, also if you are using SSL VPN, you have to install a software in your PC. But if you are gateway to gateway, it means that you just have to connect to the network through the cable or through the Wi-Fi. It means that you are connected to that private network, and then means your private network is already, because your routers already connected to another router in your branch, another office, using a VPN technology. Maybe it can be IPsec VPN. So you actually doesn't need to do anything on your laptop. You just can, from here, you can just ping the IP address, the private IP address on the branch. Okay. So let's try IPsec tunnel. This is a virtually tunnel, because all your traffic, even though we say, oh, all the traffic is go to the tunnel and go to another router, but actually in reality, all your traffic is still going to the public infrastructure on the internet. Okay, so IPsec VPN architecture, confidentiality and integrity of service are supported through authentication and encryption-based protocols. So we have this ESP and AH. These are the transform, or we should say how they encapsulate. So AH means authentication header. Authentication, if you want to use the authentication header architecture, you only can do authentication only using the algorithm MD5, HCIA1, HCIA2. Okay, but if you want to do both encryption, or if you want to do encryptions, you must use ESP, encapsulating security payloads. So an ESP can do both, can do authentication, also can do authentication and encryptions. Encryption can use the algorithm dash, triple dash, and AES. Okay, so these are the architecture you can choose. You can use one of these or both together. So security associations. Security association, or we call SA, specify the parameters for connection to establish. Okay, let's say both router, okay, want to form a VPN tunnel. What are the parameters you need to be configured? So a security association, So a security association defines a parameter in one direction. Only in one direction. So it means that router A define, okay, from here I send out these directions. What are the parameters I need to follow? Then means that I can go in, so that I can go into the tunnel. And this router B, what are the parameters I need to configure so that my traffic can go into the tunnel? Can be considered go under the tunnel. What I need to do? So both sides. So it means that both sides, their parameter need to comply with each other. Okay. Let's say from the router A side, so you need to configure local address, remote address. Local address is a local public IP of router A. Remote address is a public IP of router B. Okay, let's see local address and this local address, remote address, remote address, remote address. Can you see this? Both sides. Can you see? They are just like a pair. They mentioned my local is your remote. Your local is my remote. Okay. Then next one, SPI, Security Parameter Index, is outbound, inbound, outbound. So you can see the directions. My outbound, router A outbound is router B inbound. Router B outbound is router A inbound. So inbound is the another side outbound. So outbound is the another side, opposite side inbound. The key, the index is like this. And then the key we have also have the inbound key and outbound key. So same concept is same as the SPI, inbound, outbound. The key is to do the authentications and the encryption and decryptions. And then transform the proposal. Okay, the proposal. So proposal will mention which architecture you want to use, AH or ESP, or both, or which modes and which encapsulation modes. You want to use transport mode encapsulation or tunnel mode encapsulations. So when you create a proposal, by default, the router will by default will already choose to use ESP. ESP. Let's say ESP architecture, MD5 authentication, dash encryptions, and tunnel modes, ESP. This is the default. So, but we can change this. You can change either you want to use AH or let's say I don't want to use tunnel mode. I want to use transport mode. It's okay. Okay. Then so now we look at what is the difference between transport mode and the tunnel modes. So transport modes. Transport mode, you can see this is your original data, TCP header and IP header. If you are using AH, transport mode, if you're using AH header, the AH header will be insert between the IP header and the TCP header. And then the authentication scope is everything, the whole packet. And then if you're using ESP, you have encryptions. So an ESP header and ESP trailer, and also ESP off is insert is encapsulate behind and insert in between. So this is the scope of the encryptions: TCP, your TCP header, your data header, and the ESP trailer. Authentications scope will be ESP, TCP, data, ESP trailer. But it doesn't encrypt or authenticate the IP header, just like it's different from AH. The AH will authenticate the IP header, but ESP, no, it cannot. It won't authenticate the IP header. So if you use both, authentication header will authenticate the whole thing, the whole packet. Your ESP is the same. Encrypt the ESP, say ESP, TCP, data, ESP trailer, and then ESP authentication. These are the scopes. So usually we don't use AH and ESP together because it will increase the workload for the router to do the authentications, you do calculations, you need to do encryption, encrypt the packets, send out. The other receiving side need to decrypt the packet, so it will increase the workload for the router. So normally we don't use both together. So going to tunnel mode. So in tunnel mode, you still have your data, TCP header, IP header. Okay, but now you have the AH and another one outer IP header. Okay, outer IP header. This is different. Transport mode doesn't have this. Okay, in tunnel modes, it also protect your IP header. Means your private IP header. Private IP header is protected. And then also means in ESP, your private IP header is also encrypted. And encapsulated with a outer IP header, outer IP header, outer IP header. Outer IP header is actually is your public IP, public IP. So in this public IP later, I will show you how they do it. So next, okay. So when do we use the transport mode and when do we use tunnel mode? So transport mode is used when you are sending the, let's say, inside a private network. You want to, there's your PC, that's your host, your PC, and there's a server. You want to upload your file, your backup your files to the server, but you want to do it secretly. You want to do it with secure. So because inside the private network, you can choose transport modes just to encrypt your data, encrypt your TCP header, but you don't encrypt your IP header because IP header is needed for you to forward the data in IP in your private network. So okay, so this is when you can use transformer. You want to send data inside your private network, but you want to do it secure. But when you want to send the data over the internet, over the public network, you always use the tunnel mode because the tunnel mode can encrypt your IP header. Okay, and then how to establish a IPsec VPN? So first thing first, ensure reachability means that both sides, both router on your HQ, on your branch, on your home and office, both sides need to ping each other, can ping.
Sorry, Mr. Ben?
Yes.
Sorry to take you back. My network is a bit shaky today. The inner IP and the outer IP, are they the same or different? Are we creating
Of course, they are different.
Yeah, but is it manually or automatically generated?
After you finish configure the IPsec VPN, it will automatically generate. It's the features of the VPN.
Okay.
It's the features of VPN. Later, I will demo for you. After I finish configuring the VPN, and then we capture the Wireshark. Use the Wireshark to capture the packet. Okay, and you will see the inner IP header and the outer IP header. Okay. So ensure reachability. Both sides need to ping each other. If you cannot ping, don't even think to set up any VPN. Okay. So ping each other. Let's say go into my ESP. So both sides. So PC and PC, PC1, PC2, the IP address already configured. Now for HQ, and you configure these are the commands. So this is the interface G0. This is the IP address. This is the public IP. G0 public IP. G1 using private IP 10.0. And then this is a static route. Okay, this is a default route pointing to the internet. Next hop. So my HQ, system view, paste. Well, the internet only have two. Just configure the IP address on both interface using the this public IP. So the internet will never recognize the network 10.0 and the 192.168 never. So, and then for the branch, this is the branch and change the names, assign the public IP, assign the private IP, and create the default route. branch. Okay, after configure this, HQ will ping the branch. HQ, I use HQ to ping the public IP, both sides, 200.0.0.1. Okay, success. Success to ping means that I completed the first step, ensure reachability. Okay, next, identify interesting traffic. Okay, what is the traffic flow you want to encrypt, want to send to the tunnel? And identify interesting traffic. This is done by using the this is done by using the ACL. Okay, ACL, let's move on. For issue, I configure ACL 3000 because I need to configure source and destination traffic flow from web. Rule permit IP source. IP source from 10.0.0.0. The wildcard bit 0.0.0.255. Means that all the traffic source, let's finish behind first. Destination 192.168.0.0, wildcard 0.0.0.255. Okay, this means that all the packets with the source IP start with 10.0.0, destination 192.168.0 will be encrypted, will be forward into the tunnel. So, yeah, okay. So let me configure this ACL. We do it one by one. So HQ is okay. Now I have this. So this is from HQ side. From this network to this network. This is the ACL. So now you can guess. From the other side, it will be source from 192.168.0, destination to 10.0.0. So let me copy all this. Copy. Paste. Okay. So this means traffic from 192.168 to destination to 10.0. Okay, then I done the second step, identify interesting traffic. Okay, the third step three. So, and establish IPsec proposal. So create a proposal. So how to create a proposal is very easy, just like this. This is the command. IPsec proposal, this is a command, and put the name of the proposal, pro1. Name of the proposal, copy. Okay, and then I quit. Okay, IPsec proposal pro1. The other side, IPsec proposal pro1, but actually the proposal name can be different. Remember, can be different. Proposal name can be different, but what need to be the same is the display IPsec proposal. Let me show you. The algorithm, the encapsulation mode, the transform, or the architecture, and the algorithm, authentication algorithm, and the encryption algorithm inside the proposal must be similar. Okay, means that both sides. So this is by default, as I already told you, by default, they are using tunnel mode, ESP, MD5, and DES. Why both sides? Both sides must using the same algorithm, so that let's say when HQ forward the data to using the tunnel. So let's say HQ want to use DES, HQ are using DES. But if your branch, when receiving the branch, if your branch you set to use triple DES or AES, so how so if you do like this, the branch will never success to decrypt the data, decrypt your packet. Cannot never. So both sides have to use the same algorithm to do the encryptions and the decryptions. Okay. So both sides also have the same using tunnel modes and it's the same transform, same architecture. Okay. So from this, I completed the step 3. So now I want to create the IPsec policy. So IPsec policy, IPsec policy, IPsec policy, this is a command, this is a policy group. You can call it this P1, the name also can. This is a policy group. So in one group, you can have 16 policy. Okay, these are the sequence number. In one policy group, we can have 16 policy. And then each policy, it can be manual or auto. So here we choose manual. And then you combine in policy, you put in your ACL 3000, your proposal Pro 1. You define what is your tunnel local IP. This is the public IP of the local router, HQ. Tunnel remote, the public IP of the remote of the branch. And then SA, SPI inbound, the index inbound, ESP 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. Outbound key 6, 7, 8, 9, 10. Means the other side. You look at the other side. Okay. Manual modes, security ACL Pro 1, tunnel local 200.0.0.1. For HQ, tunnel remote 200.0.0.1. Tunnel remote at branch 100.0.0.1. Tunnel local at HQ 100.0.0.1. You can see they are in pair. So inbound 1, 2, 3, 4, 5. Here, outbound 1, 2, 3, 4, 5. Here, inbound 6, 7, 8, 9, 10. And here, outbound 6, 7, 8, 9, 10. So right here, inbound Huawei. Again, the key is Huawei, not the simple. Simple is a part of the command, the syntax command. So the keyword is Huawei. So inbound is Huawei. The other side, it should be outbound is Huawei. Here, the inbound, the outbound is HCIA. The outbound is, the inbound here is also HCIA. So both sides, this need to make sure this the configuration is correct, is accurate when you put the command. If not, the tunnel will break. So, copy.
So, Mr. Wayne.
Yes.
So what's the SPI again?
SPI, Security Parameter Index.
Security Priority Index?
Parameter. Security Parameter Index.
Oh, parameter, okay, okay.
Parameter, yeah, parameter. So later I will show you why they want to put this parameter, where they use this. This also show in the packets. Later we capture and we see. Okay, and then I already created a proposal. Now, step 5, final step. Apply the policy onto the interface. So it's very easy. Let's go to the public interface and then put IPsec policy P1.
Sorry, Mr. Bates, one more thing.
Yes.
The values we have for the ESPs, are they by default or?
Manually defined.
Manually defined?
Manually defined.
So are they representing, so what do they represent? Sorry, what, I mean, for example, the 12.345.
Why I want to use 12.345? The other side outbound is 12.345.
Yeah.
In pair, you can see if they are in pair. My inbound means the other side outbound. Can you understand this? Can you understand this?
Okay, you're associating the numbers. Okay, okay.
Okay, okay. Why I want to use this number? Later, I will show you in the workshop Why?
Okay.
I'll tell you. Okay, what's the purpose of putting this index? Okay.
Okay, that's fine.
So I go into my HQ. Okay, that's why. So I assign the policy into the interface. Actually, it's the same. Branch. So it's okay. I've finished configuring the IP set card now. Now I have to do a Wireshark capture. So I capture both private and public side. So this is which side? Okay, this is a public side, so I put on the right. So and then capture another one for the private side. Okay, now I put PC1. So now P 192.168.what? Let's see again, check again. .0.1 PC2. Okay, .0.1. Enter. Okay, finish. All ping are, the first one is timeout, never mind. At least the behind the 4 is success. It means the ping is success. Okay, you see the difference. Inside private, this is what the PC1 sent to the HQ, the router. So the right side is what the HQ router sent to the internet. Okay, so one by one. So the private ping request, second one, we look at the second one. So ping request is the same thing. Ping from source 10.0.0.1, destination 192.168.0.1. Okay, this is just your ordinary ping request packet. Okay, when going out, what happened? I say the second one, this is the ping. So you have this. Ethernet 2, say the same thing, IPv4. You see this? Right here, this is the IPv4. Oops. This is the source and destination address. This is the source and destination IP address. See the difference? The left one is using a private IP. The right one is using the public IP. 100.0.0.1, destination 200.0.0.1. This is your outer IP header. Outer IP header. And what we have inside is encapsulating security payloads. Okay, if we refer to the slides. Okay, let me show you. If we refer to the slides, tunnel mode, ESP, you can see your outer IP header. You can see ESP because it's not encrypted, but you cannot see your IP header because it's encrypted. You cannot see your TCP, you cannot see your data. You also cannot see the ESP thread because this whole part is encrypted. Okay, so inside my inside my ESP header, open. Yes, you cannot see the inner IP header. You cannot see the TCP header. You cannot see your data. Means that here, this two header is already encrypted inside the ESP payload. ESP. Okay. So that's why all the device, all the router in the public interface, they will never see your private IP. They'll also never see what is your data. Never, because they don't know how to decrypt the ESP header. They just know how to read your outer IP header, because this is a public network. So that's why the internet router can know how to forward from 100.0 to 200.0. That's all. Okay. So then check what do we have here? SPI. Okay, SPI. You see the direction. This is sent from router, sent from the HQ. So this is sent by HQ. Out, sent to outbound. Outbound. Again, we check again. Outbound. ESP 67890. So actually expected my SPI outbound is 67890. So what does this mean is, this is encrypted using the outbound. This one, HCIA, encrypted using the HCIA, the key. Okay, what happened is, when this packet is sent to the branch look at the key is 6789010. Oh, it's an inbound key. So that I know that I need to decrypt. I need to decrypt the packet using this HCIA inbound. 6789010 is my inbound, so I use back the inbound key HCIA using the same key to decrypt the packets. Then only you can manage to decrypt the packet. So can you see why? This how we use the index. Okay. So what we can expect is, if I go from PC2, okay, PC2, I want to ping PC1, ping 10.0.0.1. Same, I can see the ping request sent from this is outbound sent by the branch. Outbound 1, 2, 3, 4, 5. So at here bottom, I can see outbound 1, 2, 3, 4, 5. Outbound key Huawei. Okay, go to another side. So I can see. So another side, it become my inbound 1, 2, 3, 4, 5. Inbound key Huawei. So that the HQ router can decrypt the packet. Okay, so what happened is here, what the router do is here, this, when the router receives the packet, it process the MAC address, and then it process the destination, the IP address. See, 100.0.0.1, correct, this is me, so I receive. And then HQ router reads, oh, this is the ESP header, because on your IP header, it will also show this one. Protocol 50, protocol number 50 means the next header is the ESP header. So all the other routers in the public network, they will never know how to decrypt this header. Only the HQ router know how to decrypt this. So HQ router read, oh, this is the ESP header, and this is the SPI. 1, 2, 3, 4, 5, and then you use a key to decrypt the header, and then you will see this. you will see the IP address, the inner IP. 10.0.0.1, it should be this. 192.168.0.1 destination or 10.0.0.1. So when the router check destination to 10.0.0.1, so router HQ check or display IP routing table. So do I know 10.0.0.1? Of course, this is a direct network, called direct connected network. So but the internet router never know about this. Display IP routing table. See, never. There's no 10.0 or 192.168. Never. So all the routers in the public network only see this, all this white color, ESP, and see they forward the packet, the encrypted packet using the outer IP header, which is the public IP. So this is what the VPN done to your packets. So this is what the tunnel means. Is how they encapsulate your packets. This is your original packet. They encapsulate using this. Encapsulate. Okay. So that's all for the IPsec VPN. So what they will ask inside the exam is the scope of the encryption and the authentications. Mostly they ask about these two. Okay. In transport mode, what is the scope of authentication of AH? Maybe it gives you the answer, maybe only this or only this or all. So this you need to remember. The scope. Mostly is these two. Transport mode, AH and ESP, and also tunnel mode, AH and ESP. Please remember these two. Okay, so that's all for IPsec VPN. Do you have any other questions? As long as you know this concept, what's actually happened in the tunnel, what is the tunnel mean? Then you are okay at the end. So because all the other VPN is actually the same thing. Okay, same thing. Because they still have to forward your private packet over the public. So they must encrypt your packets. Okay, so the time for now, what's the time for now? 12, okay. So let's take a break before we go into another VPN, which called the GRE VPN. So let's take a 10 minutes break.
Excuse me, Ben. Hello, Mr. Ben.
Yes.
Hopefully, when are we taking this exam?
The exam, you will not take it straight away take this exam right after the training. No, we will give you some time to do the revisions. Okay. You can do the revision by watching the video, such as this.
And also, there's another issue I'm having because the link to get resources, every time I go there and I get a PDF, it doesn't open.
Okay, where you can get the training material, you mean?
There was a link that was sent.
Yeah. And
you said it contains a PDF that has some of these slides, but it doesn't open anytime I go there.
You mean the link is
the resource materials, yes.
Or can you just follow my guides? Or I will show you again. Can you access to the talent, Talent website? To talent. Or I also included the training inside the training info.
Okay.
The steps, how you can get your training materials. Okay. Training info. The second tab. Oops. Where's the tab? On the bottom, yes. Training materials. Okay. Training material. The second sheet. So it will be pictures and the link. Open this link. Okay, where is my picture? Working. It's loading, right? Loading very slow. Okay, I have the pictures and the guidance, the label and here, steps. You just follow and you will get to the PDF files. The training material and the lab guides. And you must create a Huawei account. It's free.
Yeah, I already have a Huawei account.
Yes, you must have this Huawei account, then only you can download. Also, you must have the Huawei account, then only you can take exam. Okay. So inside this training info, you also can see the IP network principles, keywords,
Yeah.
and also the SDP, the keywords for the SDP, this. And then also the OSPF, everything. I just put everything here. You can copy this, or after the training is finished, everything is here. You can download this and then take this as your reference. Maybe you want to conduct the training to the students. These are the keywords. Okay, you need to you can use to your revision or you prepare the training.
Okay. All the progress. You don't smart to get you get one product when you battle. Now what's in this? He dropped every other product in the market before. Coffee, that blender. Now they say you don't get stock again. So in the battle on how to get another product where we put their supply as well. So today
So how do they get the product?
now just marketers will importers. You will just go meet as they go now, we'll just enter, we'll say meet one or two of your contacts. You can get anybody who gets any container or any shipment, whether from here or Lagos. So the product where you sell basically nobody even get them.
You just the second.
You are just marketer. If they will give them for 27,000 naira and sell on 35, they make that amount for every supply. And that's what you do for different products.
Then the thing I make all of us know.
That's it. Know. This hotel job thing, just I think get hold of that.
Touch on you. Come on, to just open your Facebook page.
What is this one? What is the problem?
I won't stand up for me. I need to go. I want to change the virtue of this one, but with my problem, you see, the fear I get of money on my last card. Only 5K now I get. If I can't go use that now, I'm going to struggle to next first week.
What's the manager to that time? The power bank going to work again.
The power bank, they don't pass up.
Sorry.
I say I still won't happen. All of them just hold me from every corner.
But as the honest me, I even my source of income just they crash the same thing. Empower.
Maybe they collect them from.
You can be down on the collect. How can they do now? 60,000 they pay me for here. They don't do me anything. 60,000 plus 30,000. What if they survive me?
All of them can crash
the same time.
Now the thing where this man, that man, the way I know some pure mama worship. Now the people always supposed to start that kind of thing. When you know everybody, the people that depend on you. Everything. Now the people already just choose to do or not.
I
know say that thing for don't go about or should go this nonsense.
You're good at it. You're going outside.
Inside, I don't try to gather myself or the train itself, it won't help me gather myself over.
Okay, so let's continue to this generic routing and cancellation, GRE. This is also one of the kind of the VPN. So for either for this IPsec or GRE, this is alright. This feature is already available in all the Huawei routers. It's actually all this VPN. Many of the VPN function is already available. Actually, if your router or your home modem, your home router can support this technology, means it's free. You can set up anywhere. Okay. So let's continue with this. So GRE. So limitations, because there are limitations within IPsec VPN, restrict the ability for routes to be carried between disparate side-to-side based networks, and allowing only for static route solutions. So what do we mean here is IPsec VPN. Where's my pen? Okay, IPsec VPN restrict means you cannot use IPsec VPN to send your routes. Means you cannot send your OSPF packet. You cannot send the multicast packet, your OSPF packet using the VPN. Cannot. This you cannot using the send using the IPsec VPN. Okay, so we need another protocol. Just like another technology, just like the GRE, provide a mechanism for the encapsulation of packets of one protocol into packets of another protocol. Oops. What does this mean? So GRE means that encapsulation of protocols over other protocols. Okay, means that you can use this GRE to encapsulate your OSPF packets. OSPF packets into this. Then send it over the GRE tunnel. So it can enable the routing between remote and disparate networks. So it means that in your branch, there are so many networks here. 1, 2, 3, 4 networks. HQ also has so many networks. So you have to share all this network to the branch. The branch also wants to share all this network to the HQ. So what you can do? Maybe you can do static routes, or I want to do OSPF. I can use OSPF, but OSPF you cannot. You cannot send your OSPF packet to the public. Cannot. You also cannot send it to using the IPsec tunnel. So I can send it using the GRE tunnel. So GRE also scaling the solutions for IGP. It's a scaling solution for IGP, means that application allows for increased scalability of IGP network. IGP means inside the AS, inside AS. So IGP protocols such as OSPF, ISIS, RIP, all that. So it's capable of building a tunnel to resolve hop count limit. Hop count limit means by, okay, later I'll show you again. Okay, I forgot to show you just now in the IPsec VPN. So for all VPN, they can reduce the hop count. So physically, the packet send 1 hop, 2 hop, 3, 4, 5 hop to reach the destinations. But if you go through a VPN, it's 1 hop, 2 hop, 3 hop to reach your destinations. So I don't care how many hops I go physically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hops. I don't care. 10 hops, never mind. As long as I go through the tunnel, is 1, 2, 3 hops. So this is what we have what we have in the, if we're using VPN, regardless whether it's GRE, tunnel VPN, or IPsec VPNs. Okay, so since GRE also cannot, GRE, the weakness of GRE is no confidentiality, no encryptions. It's plain text. Okay, no encryptions. But we can put a GRE, or the GRE traffic, GRE protocol packets or GRE traffics into the IPsec tunnel. Means you cover your GRE tunnel using the IPsec tunnel. So whatever go through the GRE tunnel also go through the IPsec tunnel, means everything is encrypted. So this method we call GRE over IPsec. That's like the name right here, GRE over IPsec. Okay, next. So GRE packet encapsulation and decapsulation. Okay, same thing. GRE, this is your, let's say, this is your payload. This is your payload. This is your IP header. And then you encapsulate with the GRE header, and then another outer IP header again. Again, this outer IP header means your private, means your public IP address. And then data link, Ethernet header. Okay. So GRE also can have authentications, means that both sides, you configure the tunnel here, configure the tunnel here, you can form. So you can also put the authentication key so that you don't form a tunnel with the wrong router in the public. Okay. So also they have a keep alive message to send, because if the GRE tunnel is down, you need to the network the network need to be removed from the IP routing table. That's later we'll see how GRE works. Okay. Oops. Before this, I have to share the topology to you first. Okay. So this one. Okay, I already shared the topology in the WhatsApp group. Now I want to run the topology. So these are the configurations. An example of configurations. So I also have to put the example commands already inside the topology. Okay, and I start out the device. So I just leave it, let it put up. So GRE configurations, how they do it. So of course you have two public IP, two public interface. So in router A, this is router A configurations. You have to create in the virtual interface tunnel 001 tunnel interface. Okay, and then this tunnel interface can put the IP address just like your loopback, just like your other physical interface. IP address 40.1.1.1/24 or space 24. IP address. This you can use any IP. This as long as you can use public IP also can. Actually, you can just use the private IP. Okay, any of the private IP, and then tunnel protocol. Remember to put GRE, and then source is the public IP. okay, of the router A. Destination, public IP of router B. Then quits. Okay, and then IP route setting. Let's say IP route setting, this is a static route. If I want to go to static route network 10.1.2, this is private network. What's the next hop or the output interface? Tunnel 1. Okay, when this PC on the pin send the data to 10.1.2, the router will put into it direct, send it through the HCIA tunnel. So after that, done, the configuration is already done. So here you can see the internet. This is the IP address. The IP address is configured on the tunnel interface. It can be public IP, it can be private IP. Tunnel source. This is the public IP of the public outbound interface. This is the destination public IP. Okay, and then you can see this 10.1.2 static. Next hop, tunnel. So routes for GRE can be static or dynamic. So this is enable the KOLI functions. So just on router A on one side, you can keep alive period 3. So keep alive can define message interval and number of retries. Okay, so here you can have enable period 3 retries 3 means 3 seconds. You send the first one 3 seconds. No reply, retry first time. No reply, second time. No reply, third time. No reply, the tunnel is down. Okay, and then how many KOLI packets being sent? 4 times. At least 4 times before we make sure that the router assume the tunnel is down. Okay, then what is the primary applications for using the GRE? Okay, it's been for establishing dynamic routing between remote networks because you cannot send your multicast, your OSPF packet over the public network. So you can use GRE tunnel, okay, to send your OSPF protocol packet to another private network at a branch, another site. Okay. So what is the difference between the internet address and the tunnel source in the display interface tunnel command? So the internet address is the IP address you configure for the tunnel interface. The tunnel source is the public IP of your public interface of your router, public IP of a router, base of the interface facing the public. Yes, okay, there's a difference. Okay, so let's do the configuration here. So R1, R2, R3 are 3 commands for 3 routers. R1, I have this. Okay, this is the public IP, private IP, and then I use OSPF to form neighbor with R2, form neighbor, R2 form neighbor with R3. Then they share this network to R3, R3 share this network to R1. So they can ping. Again, it's the same thing. R1 are able to ping R3 at this interface. Both public IP, public interface are able to ping. Then only they can build tunnel. So this R2, this is a public IP, and the OSPF. And then this is the R3, private IP, public IP, OSPF. So they form neighbor. So let me copy all this. Copy. System view. Paste. Copy. System view. Paste. Copy. So then I need to wait. Okay, wait for them to form neighbors. So in meanwhile, I start the website capturing. So I capture G1 and G0. I'm ready to see the packet in the private network and the packet in the public network. So this is on the left. Oops. Okay. So I think the SPF table is already start. So you can see all the OSPF packet. This is between the R1, R2. Okay. So I have to make sure R1 can ping R3. R1 has to ping 200.0.0.1. Okay. R1 can ping R3. Okay. That's normal. Okay. Now we have to build the tunnel. Okay, let's see the tunnel, the configurations on R1 and R3. Okay. So you don't need to create any proposal, create the policy, create the ACL. No need. Okay. So we just create the tunnel, both sides. Interface tunnel 0. IP address 10.3.0.1/24. IP address 10.3.0.2/24. You do it just like both routers are direct connected with a cable, and this is one broadcast domain. Okay. And then tunnel protocol, put GRE, source, what is the public IP? This is the source, destination. The source, destination. So the source is another side destination. This destination is the opposite side source. And then I use OSPF again to form neighbor through the 10.3 network. Okay, and then share this network 10.1 to router 3. Router 3 share the network 10.2 to router 1 through the tunnel. Okay, then the router 2, you'll never see all this, never care about this. The OSPF packet sent through the tunnel. Let's do it now. One. Okay, it's formed. Let's see. Go to router 1. Let's check on what we have. Display IP routing table. What we have? Let's see here. 10.2 OSPF preference 10. Next hop is a tunnel. 10.3.0.2 tunnel 0. This is what we get. For R3. Display IP routing table. 10.1 OSPF preference also 10. Next hop 10.3.1 tunnel 0. So if you go to R2 display IP routing table, you'll never see 10.1, 10.2 or 10.3. No. Okay. So R1 display OSPF peer. How they form neighbor? So R1 form neighbor with OSPF process 2. R1 form neighbor with R2 at process 1. R1 also form neighbor with R3 at process 2 through the tunnel. Okay, tunnel. Okay. You can see it here. I put here process 1, process 2. Even though both are same area, but different process, they will never see each other different in two different OSPF process. So let's see. Let's look at the OSPF protocol packet. You see the red color, the color label. This is the hello packet sent through the tunnel. Okay. If there are two headers, still the same thing. IPv4 header, you guys see. IPv4 header, public IP, and then GRE header, and then inner IP header 10.3.0.1. Destination, multicast address. These are for hello packets, and then there's the open shortest path first. It's sent over the GRE. So for the ping, let's try to ping. PC1. We'll ping 10.2.0.1. Okay, the ping success. Let's check. The ping success. The ping. This is sent by PC1. Just as your usual ping packet, ping request. But let's check here. Oh, when you go through the tunnel, how does it look like? And go through the tunnel, you have your ICMP header, your inner IP header, and then GRE header, and then the outer IP header. So this one, all the again the same thing. All the router in the public network will only read the outer IP header and forward the packet. So only then when it comes to the router 3, router 3 read the destination, yes, receive, process, discard the IP header, and then check. Oh, this is a generic GRE header. So this is going to the tunnel. So let's see. Flag versions, all this information here, private IP, process, this header, discard, and then read the destination on private IP, destination private IP. And then forward to PC2. So this is another VPN, GRE VPN, also the same thing. They do something to the packets. They encapsulate the packet with another header. So most obvious is there's the ESP header, and then this is a GI header, and then they add with the outer IP header if you want to travel over the public network. Okay, over the public network must have the outer IP headers. Okay. So again, that's all for the GRE VPN. Let's see, what do we have? Okay. Hmm.
Hello, Mr. Way.
Yes. Yes, please.
Hello, Mr.
Yes,
Yeah,
Dr.
sorry,
Bala. Yes.
my network was interrupted, so I just came back. Which interface are we capturing, please, on the Wireshark?
Both.
Pardon?
Both on the R1.
R1. Okay.
Both. Because we want to check how the packets looks like in the private, how the packet looks like in the public. Both sides.
Okay. Okay. So we're pinging PC1 to PC2?
Yes, ping PC1 to PC2. And you compare side by side.
Okay.
Left side is a private network. Right side is the public network. And then you can see the red color label. This is the OSPF protocol packet going through the tunnel.
Interesting.
So again, so whatever the VPN do, yes, you should be able to ping. Okay. If you follow exactly the command, I just copy everything and put in the router. So if you are doing, if you type the command on your own, maybe you miss out somewhere, you can try to check. Okay. So all the VPN is actually just they do something to your packets. They encapsulate your packet with their header, either is IPsec header, the ESP or the AH header, or the GIA header, and then they add the encapsulator with the outer IP header. Then all the routers in the public network, they only check the outer IP header. Because inside the outer IP header is all the public IP, so they can forward the packet.
Yeah, okay, it's capturing, yeah. Thank you.
Yes, good. Okay. So here, let's take a break. Okay. Okay. Break time. Let's continue and let's say 1 p.m.
Mr. Bay?
Yeah. Okay, yes, Dr. Bala.
No, no, it's okay. I thought the time.
Okay. So let's continue. So before the break, we are going to finish the VPN. That's also the VPN technology. And then now we are going into another module, which is the network monitoring system. But here we're not talking about because you as compared with the previous versions, version 2.2. So we have more topics in this module, but now only we left with only one module, which is this simple network management protocol. In the short form is SNMP. SNMP is also a application layer protocol. Application layer. So let's see together who use this simple network. This SNMP. So management framework solution for TCP/IP networks were introduced as hardware and software increase in order to support rapid network growth. So SNMP was originally adapted from a simpler SGMP protocol for the use as a basis for common network management throughout the system. So SNMP has since experienced version revisions. So SNMP, the first version is SNMP V1, and then we have V2C, and then we have V3. So, however, it still remains the standard protocol for network management. Either it's V1, V2C, or V3. It's still a protocol. It's a standard protocol. It's open standard for network management. So the SNMP framework, as well as supporting management information base, we call this MIB, act as the foundation for network management, and are introduced in the support of well-rounded understanding of network management framework for TCP/IP. So SNMP is for TCP/IP, TCP/IP network. So in this section, I will describe the SNMP architecture and messaging behavior, and I will describe the functions of the MIB, and also maybe we just look at some of the configuration for general SNMP parameters and the traps. Traps means the alert. So let's see what is all this one by one. So SNMP application. In what scenario, in what enterprise scenario we use this SNMP? So it's used to communicate management information between network management station and network elements. So these are all the network elements. All your network devices, they are called network elements, whether it's a router, switch, firewall, access point, maybe other like your IP camera, include your server also. Any devices that can run, that can support SNMP protocol, it can be your network elements. Okay, so who is the NMS? NMS, or we call network management station, is actually an application. It's a software. It's a software that installed in a server. Okay, so it's a server that connected to the network so that it can monitor all your network elements, all your network devices in the network. So how this software communicate with the network elements? By using the SNMP messages. Okay, next. So before that, for example of NMS, it can be like for Huawei, we have Huawei eSite. And then further, there's a latest one, we call this iMaster NCE. This Huawei latest NMS. No. So, but the Huawei iMaster and Scene include not only the management function, OMM, it also include the controller, agile controller function, and also the insight, campaign insight for analysts. Okay, for analytic. So next, so SNMP architecture, agents exist within network elements through which NMS interact to retrieve or alter parameter variables in the MIB. So each of the network devices, or we call this network elements, they have an agent inside. Agent. So the NMS the NMS is actually sending the SNMP messages to the agent, and the agent will do whatever the NMS requests. If the NMS requests for some information, just such as the CPU utilization of the router, so the agent will take the information, the status of the CPU from the MIB object. MIB object is like CPU is one of the MIB objects. So take the status and then send to NMS. So NMS is actually interact with the agent. Okay, and then MIB objects, you can see here. So you have the roots. The roots here. So and then you can see DoD, Internet Management, MIB, and then IP, interface, system, ICMP, all this. So all these are MIB objects, like all your interfaces, that you have 24 ports or 14 ports. Each of your ports is one object. Your CPU fan is an object. Your CPU power supply is an object. Everything you can see inside the switch into the router is an object. You can have statistic, you can have object. So, and then including the RAM, the storage, everything is an object. So when we're doing configurations, we're doing command, input the command, doing configurations, that we are changing the configure IP address for the interface. Like so interface G001, we input IP address 10.0.0.1 space 24, enter, and then we are actually changing the parameter on the objects. Okay. So is that whatever we done, we changes the object. The agent can take all this, what we have done. These changes will be using the agent will use the SNMP messages sent to the NMS to make a record. Okay, so SNMP operations requests are received by an SNMP agent on UDP port 161. Okay, so this SNMP version 1, V1. So this is the NMS. This is the agent, or we call this a network elements, the agent inside the network elements. So how many packets are types of packets here is get request, get net request, set request, then get response, then 5 types of protocol packets here. 5 types of message. So that's why it says SNMP operations, 5 types of operations. So what about this UDP and the ports? So both SNMP are using UDP. Port number. What about port number is? Okay. NMS will send the get request, get next request, set request to the agent. Okay. And then the agent. Okay. If the agent receives any of these get requests, get next request, and set request, agent will respond with a get response, get response, the same thing, same type. Our get response. Okay. So, okay, look carefully, listen carefully here. So, when NMS want to send either get request, get next request, or set request, you will use the UDP port number, any private ports. Okay, you'll use the UDP private port as a source port. Destination port to UDP 161. Okay. So when the agent want to reply, send a GET response, reply to NMS, he will use the source port, UDP 161, destination port, the UDP private port, okay, by the NMS. And then this is just for these 4 types of messages. But for traps, okay, for trap, it's different. Okay, a trap is just sent by the agent to the NMS. So the agent will use what? What is the? You use any of the UDP private port. Okay, and then send a trap message. Destination UDP 162. Send to the NMS. Okay, so these are the difference. Next, so SMP V2C we improved. The only main point at here is this one. The new get bulk request. Get bulk request PDU and inform request is included. Bulk request and inform request. Okay, so what about why this get bulk request is so good about this get bulk request? So before this, when you are doing this, right? Let's say this NMS want to request for the information of port status. I have 48 ports. I have to send 48 GET requests for each of the ports. But so this will increase the bandwidth usage and the number of packets of these requests travel inside the network. So we want to improve this. We use get bulk request. Instead of sending 48 GET requests, I just have to send one get bulk request to get all the status of all the 48 ports. This is just an example. So this more efficient if using get bulk. So in compare between V1 and V2C, we should always use V2C. When do we want to use V1? Because if your network devices is very old network devices, it doesn't support V2C, then you have to use V1. But actually, one NMS it can support everything. A good NMS it can support V1, V2C, and V3, and the rest depends on the network devices. If the network elements only can support V1, the NMS will use V1 messages to talk with the agent, to talk with that SMP, the agent that can only support V1. If the network elements can support V2C, of course the NMS will use V2C messages to talk with the agent. Same as a V3. So this V1, V2C, and this V3. So V3 is further enhanced because V1 and V2C there's no security, no encryption, no confidentiality, no data integrity validation, nothing. So in V3 we further improve. We add on the security mechanism. So all the SMP message is encrypted if you are using V3. Okay, so compare between V2C and V3 when you want to use V2C and when you use V3. Okay, if you are monitoring your network element inside the private network, you can just use the V2C is enough. And if you are monitoring you're monitoring your network device, network elements over the public network, or in the open area or in the outdoor, the network device in the outdoor, maybe you should use V3. So that your SNMP messages will not be captured or the sniff captured by the other hacker. Okay, so that depends. If you are monitoring over the public network, use V3. It's more secure. Okay, and then SNMP configurations. So they'll start the SNMP agents, and the SNMP agent sysinfo versions. You can choose you want to enable V2C only or V1, V2C, V3, everything, or all. That's mean all. So and then you can enable the SNMP agent trap enable. Yes, and then SNMP trap source G1. So this interface means that the interface that you can send a trap message and it can reach the NMS. It doesn't necessarily to be direct connected to the NMS. It can be across routers, across switches, or even across routers. Also can, different network also can, as long as both sides can ping. Next, so after you configure, you can see the display SNMP agent sysinfo, and then you can see the contact person for these nodes. Who is this? Contact this person, and then physical location of the node. Where is it? And then the version running in the system, V2C. So which versions of SNMP is enabled by default? So all version is enabled by default, V1, V2C, and V3. So what is the destination port number that is used by an agent to forward traps to NMS? Okay, it's the 162. Okay, 162. Okay, so here I can open the ENSP. Let me let's take a router. Start. So let me do some configurations for you for the demo. So we say this is the router. So router, let's say we enable SNMP. Let's say check the current configurations. So the SNMP agent is enabled by default. Okay, already enabled. So what about we display SNMP agent? Question mark. Community extend sysinfo, enter. So it's already running by default. SNMP version running in the system, SNMP V1, V2C, V3. Okay, I haven't configured anything, already running by default. So what else we can do? Let's say SNMP agent. SNMP agent. Oops, dash agent. Okay, SNMP agent. What else you can have? Okay, and then community. Or just put sysinfo. Then versions or anything we have, versions. So what version we have? We can put all, everything. or SNMP version locations. Okay, what do you have? Let's say I'm Malaysia, I put Malaysia. Then what? Server room 1. Enter. And then what else? Version contact. Contact. Okay, contact. Is it there? Okay. And then SNMP agent. This one, community. At least you must configure this community reads. Okay, and then the text. What is the text? Community reads. Maybe just a string. Let's say 1, 2, 3, 4, 5. Means that when in your SNMP, in your NMS software, you also need to put in this community, SNMP community 1, 2, 3, 4, 5, so that your NMS can talk with this agent. Okay. And then SNMP agent, let's do thread enable. Yes. And then SNMP, the thread source. Thread source, it can be a gigabit interface G000. Let's enter. Okay. So that's all how you configure the SNMP for the routers. Okay, let me show you something else. That's 10.1.1.4D. Okay, this is the example of the NMS. So when you're adding device, add device. Here, you need to fill in the community. Okay, community. So you can select you want to V1, V2C, or V3. And the host name is the IP address of your network, of your network elements. So then you add device. Now device will be shown on the dashboard. Okay, so AR1. So that's all for this.
Sorry, Mr.
Okay. Yes. Yes.
After setting up this SNMP agent community read 1, 2, 3, 4, what happens?
What happens? So that when your NMS uses this community read to try to yes.
Can I see
okay.
CLI again?
CLI again. Yes, this one.
Okay, so yeah. Okay, trap the source. Okay. Okay. Thank you. It's all right. Thank you, Mr. B. I can see that you're trapping the interface, right?
Yes. Yeah.
Okay.
Okay, so our SNMP topic is until here. Let's see. Next is look at the next one. So today I go through this. All right. So we left tomorrow. Tomorrow we will finish everything. It will be IPv6 network, IPv6 routing technology, IPv6, DHCP-v6, and then the MPLS and segment routing. So I decided not to continue in the topics for today because we've been through too many topics today. So today we have been through the ACL, AAA, IPSec, VPN, GRE, and SNMP. So IPv6, we leave it for tomorrow. How about we do some questions? I'll go through some questions. Where is the questions? This one. So let's see. I haven't touched any of the questions yet. ERP. No, not this one. Let's do some questions on this. So this is routing and IP routing topics. That's like the IP routing basic principle, IP static route, and then the OSPF. So just for you to make some recap. So please start the first questions. So as shown in the figure, okay, this figure, the administrator requires router A to use static routes to preferentially send data packets to router through G1. To meet the requirements, which of the following commands can be run on router A? So preferentially router on G1. So router A. We want router A to run send packet on this. So which one? Select one answer. Which command need to be used? Means we want this to be active. This is backup. Okay. So how do you do this?
The one with the lowest preference.
The one with the lowest preference value will be the active route. So how do you do this? What are the commands you can use? A, B, C, D. Which one?
We can use D.
We can use D. Yes, it's D. The answer is D. So we change the preference for this path to 70. So by default, this is 60. So this will be the active path. Okay, next. So which of the following OSPF packets can be sent to request the local lacking LSAs? Select one answer. Request.
Hello?
No. Hello is to neighbor discovery and maintain neighbor relationship.
Is it the LSR?
No.
No.
The answer is
LSU.
link. Again, Simon.
That question is tricky. I don't know.
LSU. D.
No.
What is the LSA, sir? LSAC. LSAC.
Link state acknowledgement.
Right.
Acknowledgement.
Link state R, link state R. Yes, this is the answer. Link state request. That's all. Okay, link state request.
Mr. Dr. Paula mentioned, he said,
I mentioned this C.
Each of these message protocol packet has its own function.
I mentioned
so
LSR.
if you link state request,
Yeah.
okay, LSR.
okay.
Okay, which of the following OSPF versions is specific to IPv6?
A.
A is for IPv4. Yes, C is for IPv6. Okay. V2 is the IPv4. What we are learning, what we are calling, just call it OSPF.
I thought we
is V2. Okay. Okay. Next, which of the following statements about static route preference on Hoi devices is false? Select one. Which statement is false?
I think C.
No.
Then it's A. Then if it's not C, it's A.
I have the false statement. No.
Then A is false.
Just B also false. You don't think so?
A is false.
B also false.
Ah.
Because static route preference range.
Yeah.
What you can have. I see, just compare. IP route static 0, 0, 0, 0. Preference, let's say put next hop. Preference. Okay, question mark. Preference value range 1 until 255.
So what is 0 by default?
What is 0? The direct routes.
So is 0 is used for what, sir?
0, the direct routes. Display IP routing table. The direct routes preference is 0.
Oh, direct routes. Okay.
Yeah.
Sorry, I didn't know that one.
Yeah, so this is wrong. So for whether the 255, the route cannot be used. Actually, this is very subjective. Okay. If you use this this simulator to put the preference 255, it can work, sir. It can work.
Yeah, part of the range.
But somehow I read from somewhere, from the Huawei website. It stated that if the route preference 255 is considered expired route. So the best answer is this. Confirm, okay, you cannot start from 0. It's 1. Okay, next. So to enable router A to communicate with loopback 0, router A to communicate with loopback 0. Okay. Or router B on the network shown in the figure, which of the following command needs to be run on router A? So which command to be run on router A? All 4 are static routes, IP route static. Select one answer.
A is correct.
Again, A is correct. Are you sure?
Oh, the next hop is
IP route static 10.0.22. Everyone are 10.0.22. Okay. And then.
Oh, the next hop is B. That of B. So that is B. B.
Next all is B. Yes. Answer is B. Okay. 10022. This is /32.
Is correct.
By 252.5. Yes. Correct. Next one. Which of the following brackets is used by OSPF to describe its linked state database? LSDB. Select one. A, B, C, D. Hello. Yes. Again. To describe its linked state database.
I think it's LSU. I'm not sure, but I think LSU.
Okay, so I think you must refer to this.
Yeah.
What is this? Hello, database description, DBD, or you can call DD. And then your link state request, you request for LSA. Link state update, you send LSA. And then link state acknowledgement, you receive LSA, and then you acknowledge, yes, say thank you. Okay, so which one? Of course, database description, the DD.
Yeah, totally forgot that.
So which of the following statements is true about the OSPF DR? Okay, select one answer. The DR is elected in preemption mode. If the priority of an interface is 0, the device where the interface resides cannot become the DR.
C.
The DR must be the device with the highest priority on the network.
C.
Are you sure? Is it a must?
It's not a must because the ID can also be used.
ID also can be used. Last
Yes,
one,
but
a router with a larger router ID is selected as a DR.
Yeah, the priority is the first.
B.
B, the answer is B.
What?
Yes. Okay. If the router or the interface is 0, the device where the interface resides cannot become DR.
B, yes.
Yes. B. If your priority is 0, means that you not join election or you resign. Even now you are DR or now you are BDR. You change to 0, you straight resign. Don't care.
Okay.
Okay. But for the DR must be the device with the highest priority on the network. What if the election period already ended? Okay, so not necessary. Not always with the highest priority on the network. So same as for router with the larger router ID is elected as a DR. Not necessary. Okay. So next one, a router runs OSPF and no router ID is specified. This one. The IP addresses of all interfaces are as follows. What is the router ID of the OSPF enabled router? If we don't manually configure, so how to get the router ID? Which one? A, B, C, D.
The one on the loopback interface?
The one on the loopback interface, yes. But which one?
That would be 10.0.1.1.
Is B.
B. 10.0.1.2.
10.0.1.2.
Or the higher one, yeah.
The highest one. Yes.
Yeah, that's right.
If you don't have loopback, then only you take the physical interface, Ethernet.
Yeah. Yeah.
Okay, next. So the router ID of the OSPF process takes effect immediately after being changed. False. Non-preemption. Okay. Non-preemption. It won't change immediately unless you restart the OSPF process. Okay. Yeah. This one you can do the ENSP, then you can know. So which of the following statements about the IP route static 10.022.255.255.255 next hop 10.0.12.2 preference 20 command are true? Select one or more answer.
The next up is .2a.
Okay, this one correct. This is the next hop. The next hop 10.0.12.2. How about this? The preference of the route is 20. Yes, 20, that's here. Okay, these two, either one. Destination IP address, which one? You can guide the C, yes, C, 10.0.22, 10.0.22. Next, as shown in the figure, the host has ARP cache. Host A sends a data packet to host B. Host A sends a data packet to host B. Which of the following are the destination MAC address, destination IP address? Okay, and destination IP address of the data packet. Host A send the data packet to host B. Send to host B. Which of the following are the destination MAC address and destination IP address of the data packet?
Hello, Mr. Bay.
Yes, so there's a packet. Host A forward to router, router send to host B. Yes.
It's okay. Sorry, I lost contact. My phone just went.
Okay.
All right, I'm following now. Thank you.
B. Destination MAC address is D.
B.
Destination MAC address is
MAC address
B.
is D. D.
MAC what? MAC B, MAC C, MAC D?
B.
No.
B, MAC B.
Yes, B is correct.
Destination IP?
Hello.
Yes.
Level 0.0.1.
Host
All the
A
host
send to host B.
response.
Host A send to host B.
Yeah, host B responds with its IP address and its MAC address, and the IP address is 1.0.0.12.1, and the MAC address is MAC B.
So the destination IP address is 11.0.12.1. Yes.
Yeah.
But how about the MAC address?
The C is correct. The MAC address is MAC C. The MAC address is MAC C.
MAC address is MAC C. Yes.
That's of the router B?
Yes.
Of the router.
Yes.
The router can have. Hello?
Yes. This is the answer.
So the mark will change at the router level?
Of course.
The default gateway is going to be
This
the
is
destination
two
MAC address.
different domains, two different
Right.
networks.
Okay.
Yeah.
Mm.
Okay.
So the Ethernet header will keep on
yeah,
changing.
yeah.
The source and destination MAC address will keep on changing between networks.
Hmm.
But the source and destination IP address never change.
Right.
My login.
Okay,
And
next.
I want to check on him then.
So on the network shown in the figure, after OSPF protocol state is stable, what is the neighbor status between router B and C? Okay, neighbor status between router B and router C.
Router B.
We're doing question and answer. You're still around now.
Yes.
No,
Tell me, I don't.
So I will show up.
Router B and router C. Is that full?
No.
When is the priority 0? Okay, priority 0, priority 2. Okay, 255 is 0.
The question, please. I can't see the question.
I think it's a two-way.
Mr. Bear, the question.
It's a two-way.
After the OSPF protocol is stable, what is the neighbor status between router B and router C?
It should be a two-way.
Yes, it's a two-way. Because router B is priority 0. Router C also priority is 0. Both are DR other.
Yes.
So DR other only form two-way with DR other. Okay. If the administrator does not configure backbone area, the routers automatically make up the backbone area. Is it auto or not?
False.
False.
Manually
You have to configure. The backbone area is the area 0. If you don't configure, there's no area. Another questions. After the OSPF protocol is stable, which is the neighbor status between router A and router B?
Router A and router B.
Yes. Router A, router B.
Router A is the default. It looks like a full.
Is full.
Yeah.
Just router A, fixed positive will be the DR, and then B and C are the others. So they form full status. Full. Okay, next. Okay, this one too big. Yes. Okay. So on the network shown in the figure, which of the following command can be used to enable router A to forward data packets with the destination IP address 10033? Router A want to forward the packet destination 10033. So select one or more. Oops, this one. Okay.
10
The
0.
answer here is, let me see. This one.
10 0.
A, B, C, D. The last one have two commands.
B. The next hop is block 2. We have to use any. Study.
A and C.
A and C.
Huh?
Because you see,
A and C.
see the 10033, next hop 10012. Yes. You put the default route 10012 also can.
Mm-hmm.
How about the last one?
The last one, there's no path to 10.0.2.2.
Yes. You see this? You tell the router. If you want to go to 10033, go to 10022. How to go to 10022? Go to 10012. So these are the connections between these two routes. But can these commands work? Is it doable? You can type, but can this work? Answer is can. Yes, it can work. The router will summarize it. Okay, if I want to go to 10033, go to 10012. Yes, the router is very intelligent. Okay. Next, as shown in the figure, router A has the following configurations. Which of the following statements are true? Router A, these are the router A configurations. So we have two parts. So 10012.2, another one, another next hop, 10021.2, preference 40. So means this one is the active, this one is the backup.
Yeah.
So, if G1 goes down, the outbound interface of the route to 10022 is changed to G2 in the routing table of router A. No.
It's already active, so.
Yes. So no. In the routing table of router A, the outbound interface of the route to 10022 is G1.
Of A, outbound.
G1 or G2?
No, that's false.
So it's C. If G2 goes down, the outbound interface of the route to 10022 is changed to G1 in the routing table of A. Yes. Okay. Which of the following statements is true about direct routes? One answer.
Direct route. Did they?
Yes. Direct route has the highest priority. Let's see.
Yeah.
Okay, this one. Which of the following statements regarding static routing and dynamic routing is incorrect? Which one is false statement? One answer.
Which of them is false?
Yes, which one is false?
Static route.
I think it's real. Static routing can be easily configured and managed on the enterprise network.
This is
B.
C. Because static routing just easily.
This is false statement, incorrect statement. Static route cannot automatically recover, but it is easily configured. You don't need to configure the area, the network, that's no need. You just put the network, subnet mask, and the next hop, done. Easy to configure, but cannot recover automatically when there's a topology change. So this one, refer to the command output. Which statement is true regarding this command? IP route static 10.0.12.0 is a subnet mask. This is 24. This is the next hop, 192.168.1.1. Select one answer. True statement.
Which of them is true, right?
Yes, which of them is true? Okay, I heard the
looks like
answer.
B, right?
Again?
They represent a static route.
This is a static route command. IP route static.
Looks like B.
Looks like B.
Because we're assigning to the router, we're assigning the interface to the outbound of the router is the 10.192. Sorry, is the 10.0.12.0.
Yeah, this one. The destination. This is the next hop.
Yeah.
This is a static route to 10.0.12.0 network. This is the destination.
Yeah.
And which of the following network types are supported by OSPF?
Can you explain that A?
Okay. If the router has learned the same destination network via a dynamic routing protocol. Okay. You mean you want me to explain the?
Are we still
on
on
the
A?
static route will take preference. Is it true or false?
This is false. Only this one is
get
the true.
Explanation for that A statement on quiz. Okay.
I want the true statement. Only one is true.
21, right?
Yeah. Now 21. Which one network type is supported by OSPF?
Point to point. Point to point.
Point to point.
Broadcast.
Broadcast.
Point to multi-point.
Point to multi-point.
And NBMA.
NBMA, everything. Oh. Okay.
I forgot that.
Okay. On the network shown in the figure, if all routers run OSPF, which router is elected as a BDR? A, B, C, D. Which one?
A.
BDR. I want BDR.
Oh, BDR. Back up the next one.
Yeah, most of them. Some of them.
200.
200. Router B.
Most of them don't.
DR is the router A. Okay, next. Which layer of the OSI reference model does a router work at? Which layer?
Network. Yeah.
Network
We need
layer.
to confirm.
Which of the following field is not included in the OSPF hello packet? Select one.
It's not included, right?
Yes, only one answer.
What is the system doing there?
Yeah, you're saying why is it here? Okay, so this is the answer. Why is it here? Because it shouldn't be here. Okay. Next, what is the default interval for sending OSPF hello packets on a broadcast network?
The default interval.
Yes, the hello timer.
I think that's 40
10
seconds.
seconds. 10 seconds.
10 seconds. Okay, 10 seconds. So the output of the display OSPF interface verbose command on the router is as follows. Which of the following statements are true? So these are the statements. So A, B, C, D. Select one or more. Okay. Last.
The diagram is hiding. Okay.
Yeah, this one, the diagram. These are the output. Display OSPF interface verbose. These are the
B is correct.
status. B is correct. The router ID of the router is 10011. 10011. Yes.
Let me see the DR status. The DR.
The DR priority of the local route interface is 10. How should I put?
D is correct.
Local router. The local router is BDR. Yes.
What is the cost value?
A.
Cost value. Cost value. The
Cost
priority is of
value.
what? Is
Cost
that the priority?
value. Priority 1.
Yeah.
Oops. So this 10. This 1. So wrong. Okay, so 3 answer. Okay. This is a cost. Okay. This is a cost. This is a priority. The state. Router ID. Okay. So let's see which one. See this one. The last question is on the network shown in the figure, the host has ARP cache. Which of the following statements are true? The host has ARP cache. So we have put a picture. You can see. They have cache. So select one or more. Answer. The following ARP cache entry exists on host A. 10.0.12.2. Next C. Host A and host B can communicate with each other.
After sending out an ARP request, host A would have learned that, yes.
Yes, the host has ARP cache. There's record in their ARP cache. So the following ARP cache entry exists on host A. If this exists in host A, 10.0.12.2, next C. Yes,
Yeah.
this the gateway max C 10.0.12.2 max C. Host A and host B can communicate with each other.
Is that a broken link in between them?
No, there's just a
Okay.
diagram. That's a diagram. Okay, it's connected. Okay. can host A and host B can communicate with each other. Is it correct?
If it's established as a communication.
Yes. Don't care about this, huh? It's connected.
The broken line is a bit confusing there.
No, we won't purposely do this, huh? Okay. It's connected. Both sides, host A and host B have gateway. Host B also a gateway. So they can communicate. Okay. So that's all. Only 2 answers. Static route need to configure on the router? No. Router can use the direct routes. Following ARP cache entry exists on host A. 11.0.12.1 MAC-B. This should be exist on router cache table, ARP cache table, not the host A. Okay, can understand this? And then we finish for today. So we continue tomorrow.
All right, thank you.
Okay, thank you. Okay, if you don't have any other questions regarding the training or the class or the topics,